Hi everyone. So we are already done with our complete syllabus of EMFT, right? We have done all the chapters. We started with vector algebra, vector calculus. Then we saw the Maxwell equation, EM waves, transmission line, waveguide, and antenna array. So all these chapters we have seen. The syllabus is completed, but now we are going to cover some miscellaneous concept. Like from each chapter, there has been some topics. From those topics, one or two questions has been asked in the GATE examination till this date. I'm not saying that one or two question is asked every year. Till this date, from some miscellaneous concept, one or two question has been asked. So those concepts we are going to cover here. Okay. So these are not that important, but since it has been asked in the examination, so it might come up again. But these are not that important. So this video will be completely miscellaneous. Here I'm not saying that we are covering transmission line or we are covering EM wave or we are covering waveguide. Nah, nothing like that. In some slide we will be studying about transmission line. In some slide we will be studying about waveguide. In some slide we will be studying about EM wave. In some slide we will be studying about antennas. So very random it will go. Okay, so first let's get started with the types of transmission line. This is our first topic of this video. So when we were studying transmission line, which kind of transmission line did we study? There were two wires. In between there was some dielectric medium and then we connected a load. This is the transmission line that we studied. Two wire and in between there is a dielectric and then there will be a load. So this is known as two wire transmission line. This is your two wire transmission line. Now there are other types. This is also one of the type, planar line transmission line. Planar transmission line. So here there are two conducting plates. Here there are two conducting plates. In between there is a dielectric. This is your mu r epsilon r. Here in between there was a dielectric. Mu r epsilon r. Okay. There is another type of transmission line, that is coaxial transmission line. What is that? Coaxial transmission line. So here there is a smaller conductor and outside this smaller conductor there is a bigger conductor. This smaller conductor is having a radius of A. This bigger conductor is having a radius of B. And in between these two conductors, this is one of the conductor and this is the other conductor. In between these two conductors, there is dielectric. So in this area, there is dielectric. In this area, there is dielectric. Okay. So this dielectric is there, that is mu r epsilon r. Now, whatever the topics we studied like a wave equation, we studied voltage wave equation, current wave equation, then we studied about standing wave patterns, we studied about reflection coefficient, we studied about bounce diagram, we saw the S parameter, we saw a lot of things we studied in transmission line. So all the questions were based on this line only. And in the examination as well, all the questions will be asked on this particular line only. They will give two wire transmission line and based on that they will ask you the questions. But the thing is, from this particular transmission line, from coaxial transmission line, there can be some questions as well. From which transmission line? From coaxial transmission line. What kind of question? So these are the parameters of coaxial transmission line. These are the parameters of two-wire transmission line. These are the parameters of planar line. Like this is the value of R for coaxial line. This is the value of L for coaxial line. This is the value of G for coaxial line. This is the value of C for coaxial line. And all these are parameters for two-wire line as well and planar line as well. But which is more important? There are only, like, it is not practical to mug up all these formula, right? You cannot mug up all these formula. If I ask you to remember all these formulas, that what is the value of inductance for planar line, will you be able to tell me? No, it is not practically possible to remember it. So which two formula we remember? We remember the value of L. We remember the value of L for coaxial transmission line and we remember the value of C for coaxial transmission line. That's it. Only these two formula we remember. Now secondly, on these these two formula has been asked in the examination. Okay, these two formula has been asked in the examination, but they were asked in 2014 as far as I remember and 2015. And at that time you had electrostats and magnostats in your syllabus. I'm talking about ECE students. ECE students previously in the previous syllabus they had electrostats as well and magnostats as well and electromagnetic induction as well. So all these three topics were also there in your syllabus as well. This I am talking about ECE. So in electrostats and magnostats, we study about this coaxial line and there we study this formula as well. The formula of C, the formula of L. So are you understanding the point why they asked this question? Why they asked the formula of L, why they asked the formula of C? Because we already studied in electrostats and magnostats. But since this topic is common for electrostats and magnostats and also it is common for transmission line as well. So it could have come in 2014 and 15. But now there is very rare chance that these kind of questions can be asked. But still, if it is asked, then 100%, then I cannot say 100%, but higher chance is there that they will ask only the L value or C value for coaxial line. So what you are going to remember? You are going to remember only two formula out of all these formulas. Which all two formula you are going to remember? The formulas are, for coaxial transmission line, the value of inductance, Henry per meter obviously, that is mu upon 2 pi into ln b by a, and value of capacitance for in farad per meter, that is 2 pi epsilon upon ln b by a. Only two formula I am asking you to remember. This is the worst case I am asking you to remember. Even if you can't remember it, then you can drop it. But at least if you are preparing completely for EMFT, then these two formula you can keep in mind. Write it on some paper or write it on in your WhatsApp group, anywhere you write it down and try to remember these two formula. Because two questions has been asked till this date. And why they were asked, the reason also I told you. Okay, so there is no concept that how this formula is derived. If we were studying electrostats and magnetostats at that time, we could have derived it, but as of now you need to remember the L and C formula. And if they ask you the value of Z0, what that would be? Under root L by C. So you can put the value of L here, you can put the value of C here, you will get the value of Z0 as well. Okay, so let's see what kind of questions has been asked. So this kind of question has been asked. A coaxial cable with inner diameter of 1 mm and outer diameter of 2.4 mm. So what do you think, what is the value of A here? 1 mm, the smaller diameter, outer diameter 2.4 mm, is filled with the directivity of relative permittivity 10.89. Now some people would be thinking that, sir, what if the question is asked from this particular formula? Now if it is asked, then it is asked. You can drop it, right? You cannot, if you want to remember all these formula, if you feel like that I can remember all these formula, then you can remember. What if the question is asked from here? If it is asked, then it is asked only. You cannot do anything. Are you getting this point? Like, it is not practically possible to remember these kind of formula. And the way they are setting up the question paper, I don't think they will ask these kind of questions. They are setting up a very good conceptual question paper nowadays. If you have seen previous year questions, like if you pick up the question paper from 2018, you will realize that there is hardly any formula based question. So I don't think any question will be asked, but these questions can be asked in your test series. These questions can be there in PYQs. So when you solve the PYQs, when you solve the test series, you will feel like that sir did not teach enough. So that's why I am teaching it. Okay, as a student, if you don't have time, you can ignore it, but don't ignore the complete lecture. Whatever that you can ignore, that I will tell you. But if you want to cover it completely, then you can remember these formula as well. But there is very rare chance that these kind of questions would be coming. Okay, there is option E as well, no? Yeah, there is option E as well, 15.91. Yeah, so let's solve this question. This question was asked in GATE 2014 as far as I remember. So no option was matching, so that's why I have put the option E here. No option was matching there. So yeah, we were solving this question. So relative permittivity was 10.89. Mu naught epsilon naught value we already know. What we need to find? Characteristics impedance. So for that, what we need? Under root L by C. So what is my L? My L is mu upon 2 pi into ln b by a. And what is my C? My C is 2 pi epsilon upon ln b by a. Just the reciprocal I have written. Reciprocal of this formula. I have written 2 pi epsilon ln b by a. So what is getting cancelled? Nothing is getting cancelled. So what we are getting from here? Z naught we are getting as under root mu by epsilon into ln b by a. Ln b by a square is there, then under root is there. 2 pi square is there, and then under root is there. What do you think? What is the value of this one? Can you let me know? The value of this quantity is 120 pi mu r epsilon r. Say yes or no. Into ln b by a. What is ln b by a? 2.4 divided by 2 pi. So what you are getting? 60 into ln 2.4 into what is mu r? Mu r is not given, so it is 1. Epsilon r is given, that is under root 10.89. So what is the value of Z naught you are getting? If you solve it, you will get the value of 15.91. Okay. So this is the answer. Now this question is completely formula based, no? Like completely formula based. Now it is very surprising from IITs that they were not able to solve this question correctly. Like there is no concept, nothing. Just see it and solve it. Like 10th class student can also solve it. If you give them the formula, class 10 student will also be able to solve it. But this is very, very surprising that IITs were not able to frame this question correctly. They did not even frame any correct option. This is the correct option. It was given as MTA by IITs. But this is very surprising. Now what if you are in the examination, you have remembered these formulas with good amount of effort, you remember these kind of formula, and you see this question, this is the first question in your examination, you see this question, you apply the formula and you are not getting any option correct. What will be your mental state at that time? So this is like very, very disappointing from IITs. Like they don't even care about the question paper of GATE. This is what it shows. If they care a little bit, then they will be able to frame the question correctly. Like even, I guess even 10th class guy can frame this question correctly. If he needs to frame, he can also frame the question correctly. But this was very surprising from IITs that they are not able to frame these kind of questions correctly. Like every year there has been 3 to 4 marks MTA. Not 3 to 4 marks, 3 to 4 questions MTA. MTA means marks to all. That means they have framed the question in a wrong manner. So that is very, very surprising from IITs. Very, very surprising and very, very disappointing as well. So be it IITs or ISC, I'm telling about both. So yeah, but in the examination, if you feel like that an option is not matching, that then immediately drop that question. Okay, do not spend your time, because it might happen that the question has been framed in a wrong manner. It might happen. Well and good. Okay, so just a message I wanted to give. So this was the first question. Let's see the second one. So for a coaxial, inner radius, outer radius has a capacitance of this much. So what is the formula of capacitance? 2 pi epsilon ln b by a. This is the formula of capacitance. So from here what I can see is that capacitance is inversely proportional to ln b by a. So initially capacitance is 172 picofarad. When it is 172 picofarad, at that time the ratio of outer radius to inner radius was 5. Now if the outer radius to inner radius ratio is doubled, that means now the ratio has become 10. Then what will be the capacitance value? Did you understand what did I do here? Both are inversely proportional, no? So C2 by C1 would be equals to ln B1 by A1 divided by ln B2 by A2. What we are finding? We are finding the value of C1. Let's just say C2 is given, ln B2 by A2 is given, ln B1 by A1 is also given. So we need to find the value of C1. So just inverse proportion I have written. Are you getting this point? So this is how I will solve it, because they are inversely related. So what is the value of C? 172 into ln 5 divided by ln 10 picofarad. So value of C you will get, as far as I remember, it was something around 122.23, or let's solve it. .23 picofarad or 22. So C value was 120.22 picofarad. That's it. Okay. This was very simple, straightforward question. So these two questions has been asked, but I don't think these kind of questions will be coming again. So only formula based question, just remember these two formula and it will be all okay for you. And why these questions were asked on these two formula? Because in in electrostats and magnetostats, we study about these two formula. We study about inductance, we study about capacitance there. That is the reason why, that's why they asked it. But nowadays, I don't think it could be asked. Okay. So in your upcoming examination in 2025, 2026 and 2027 or 2028, I don't expect these kind of questions to be coming in your examination. Yeah, so now let's study the second topic. Okay, so we are done with the first one. There we studied about the types of transmission line. Now we are going to study the second topic, that is related to EM wave. So when we were studying about our normal incidence in EM wave, when we were studying about our oblique incidence in EM wave, there I taught you a formula of reflection coefficient. What do you mean by reflection coefficient? So the thing is, there is a boundary in between. This side you are having medium 1, this side you are having medium 2. So this medium 1 will have its own alpha beta, it will have its own alpha beta, it will have its own sigma, it will have its own neta, it will have its own lambda as well. Similarly, and certainly mu and epsilon as well. Similarly, this medium will have its own alpha, beta, sigma, neta, lambda, mu, epsilon. Only which things remain constant? That is omega. Omega never changes, right? Omega will be same. Here it will have also omega. This will also have omega. This will never change. This we have already studied. Now what do you mean by reflection coefficient? From here the wave is coming. If the wave is coming from here, now if there is a change of medium, some wave will be transmitted and some wave will be reflected back. So the reflected back wave divided by the incident wave. What is your reflection coefficient? Reflection coefficient for electric field. The magnitude of reflected electric field divided by the magnitude of incident electric field is given by reflection coefficient. And what was the formula? That is important. Neta 2 minus neta 1 divided by neta 2 plus neta 1. Right? So this was the scene here. This we have already studied. But when we study this particular topic, here the medium 2 was spread till infinity and medium 1 was spread till infinity. Basically, there is a boundary in between. Now, from here till infinity, the complete medium is medium 1. And from here till infinity, the complete medium is medium 2. Are you getting this point? Now, what do I do here is that from here complete medium is medium 1. So, I do not do anything with this. In between, I introduce another medium, that is medium 3. For a very small length, in between, I am introducing another medium, that is medium 3. What do I mean by this particular statement is that this is my boundary. So this is my medium 1. I do not do anything. In between, I am introducing, for a small length L, in between, I am introducing another medium, that is medium 2. And after that, again medium 3 is there. So this kind of a diagram we are going to get. So this is the reflection coefficient that we have written. But what kind of diagram we are going to get? This kind of diagram we are going to get. This is the medium. This was the boundary. It was spread till infinity, but in between we have introduced another medium 3 for a small length. So here, let's just say here there is air, and let's just say this is glass. This is glass, this is air. But in between I introduce another medium. Let's just say this is water. So in between I introduce another medium. So this is what I am doing. Okay, so let's get back to the previous slide as of now. In previous slide, what I want to write the reflection coefficient. So what was the reflection coefficient? Reflection coefficient was neta 2 minus neta 1 divided by neta 2 plus neta 1. And what was the condition for zero reflection? Or you can say complete transmission. What was the condition? Complete transmission. The condition was neta 2 should be equals to neta 1. Because if you want reflection coefficient to be 0, that means neta 2 should be equals to neta 1. This was the condition. Right? Now in this one, finding reflection coefficient was very easy. You started from here, neta 1, neta 1, neta 1, and then you went to this medium, neta 2, neta 2, neta 2. Complete was neta 2 here. Here complete was neta 1. But now what is happening? We have introduced another medium in between. So here neta 1, neta 1, neta 1. Then for a very small time, neta 3 is there, and then complete neta 2 is there. So how will you find reflection coefficient here? If I ask you to find reflection coefficient here, what will be its value? So you need to remember this formula. What will be the value? That would be neta in minus neta 1 divided by neta in plus neta 1. What do I mean by that? That looking from here, the equivalent neta that I can see is neta in. If I ask you, looking from here, the equivalent neta that you can see is neta 2. Looking from the boundary, the equivalent neta that you can see is neta 2. From here, looking from the boundary, the equivalent neta that I can see is neta in. It is not neta 3, it is neither neta 2, it is neta in. And what is the value of neta in? So the neta in is, do you remember the transmission line? This is the transmission line, right? This was our transmission line, and it was, let's make it here. So I am writing down the formula of neta in, that is also very important. But let's relate it. I am going to relate it with the transmission line. So this was your transmission line, which was connected to load. So this load was ZL, and the characteristics impedance of the transmission line was Z0. And we used to write down the formula of Zin. How did we write down the formula of Zin? That was equals to Z0 into ZL plus JZ0 tan beta L divided by Z0 plus JZL tan beta L. Similarly, and beta was coming for the medium here, right? Beta was coming for the medium here. Now this medium will have its own beta. This medium will have its own beta, and this medium will have its own beta. Say yes or no? Because all are different medium, so they will have its own beta. Now beta was coming for this particular medium. This transmission line between the wires of transmission line or between the plates of transmission line, you can say, if you are using 2-wire transmission line, then you will say between the wires of the transmission line, whatever the material is there, that will have its own beta, and that beta would be coming in this formula, right? Similarly, you need to write down the formula of neta in the very same manner. How will you write down? First, what was coming? Z naught. So here, neta 3. This you can assume as a transmission line, and that is this medium is working as a load, and this is your transmission line. This is how you can assume this particular scenario. So what will come? Neta 3 is acting as a Z naught. Neta 3 is acting as Z naught. So neta 3 into neta 2 plus j neta 3, j neta 3 tan beta L. Okay, I need more space. Divided by neta 3 plus j neta 2 tan beta L. Is it tough to remember? Absolutely not. Why it is not tough to remember? Because you remember the formula of Z in very carefully. But here, which beta will come? Beta of this medium, here beta of this medium will come. So that is very, very important. Here beta 3 will come. People will remember the formula neta 2 plus j neta 3 tan beta L upon neta 3 plus j neta 2 tan beta L. This is not very tough to remember because you can relate it with the transmission line. But the thing is, which beta will come here? The beta of this particular medium will come, because this is working as your transmission line and this is working as your load. So neta 2 is working as a load, okay, and neta 3, the new medium that is having a length of L, that is working as a Z naught. Neta 3 is working as a Z naught and neta 2 is working as a load. So neta 3 into neta 2 plus j neta 3 tan beta L divided by neta 3 plus j neta 2 tan beta L. This formula you already remember. You start with Z naught, then you go to ZL, then again Z naught, then again Z naught, and then ZL. This is not that tough to remember. I hope you have remembered this formula. So now you are going to remember this formula as well. So let's see some special cases. Okay. So if your length is 2 lambda by 4, odd multiple of 2 lambda by 4. So if the length is odd multiple of 2 lambda by 4, then let me know what will be the value of neta in. Can you let me know the value of neta in? For transmission line, if my length was lambda by 4 or 3 lambda by 4 or 5 lambda by 4, so what used to happen? Z naught square by ZL, right? My Z in was Z naught square by ZL. So similarly here as well, what will happen? Neta 3 square by neta 2. Neta 3 square divided by neta 2. Because what is working as? Here I will just write down one thing, that my Z naught is equivalent to neta 3 and ZL is equivalent to neta 2. So this should not be that tough for you to remember. So similarly here, this will be your neta in. And then can you find the reflection coefficient? Certainly. Neta 3, okay, I'm not writing down the formula, you can find the reflection coefficient. And what about this neta in? For if the length is multiple of lambda by 2, so what will be your neta in? Do you remember? If the length is multiple of lambda by 2, so here in transmission line, if our length was multiple of lambda by 2, then what used to happen? The complete load will come in front. Like this is my transmission line, this is ZL, and if the length is multiple of lambda by 2, so from here what will be the Z in? You will see the load will come out here. Z in will be ZL only. So similarly here, neta in will be equals to, what is my ZL here? My ZL is neta 2. So these are two special cases. And nowadays these questions are asked very much in the test series. I am seeing the test series of MedEZ, I am seeing the test series of ACE Academy as well. So there they are asking these kind of questions. I don't know why, what is the reason, but they are asking this kind of question, because what could be the possible reason is that in GATE 123, one question was asked on this particular concept. On this concept in GATE 123, one question was asked. And before GATE 123, no one used to teach this concept in their notes. Just being honest, okay? And even if I had been the educator at that time, I would not teach it, because no question has been asked ever. But in GATE 123, since the question has been asked, now everyone is teaching it, and that is correct only. That is correct as well. Like this is the job of an educator. Everyone is teaching it as well, and they are framing the question in test series as well. But those who are following the older courses, then they might not be able to get this concept. So that's why I am teaching it here. Okay, yeah. So what will be the condition for no reflection? What is your gamma, that is gamma neta in minus neta 1 divided by neta in plus neta 1. If you want it to be 0, so that means gamma in should be, neta in should be equals to neta 1. That is the condition for no reflections. Let's see some questions. So here this is medium 1, this is medium 2, medium 3. You need to find reflection coefficient from 1 to 2 and reflection coefficient from 3 to 2. From here to here, if my wave is going from here to here, then what will be the reflection coefficient? Or if my wave is going from here to here, then what will be my reflection coefficient? This you need to find. All clear? And what is the length? Length is 3 lambda by 4. That means if I see here, now this is the solution I am writing down. If I see from here, I call it neta in 1. I am calling it neta in 1. And if I look from here, so this neta in I am calling as neta in 2. So what is my neta in 1? My neta in 1 will be Z0 square by ZL. Z0 square by ZL. So neta, okay, this I need to give the names. So this will be my neta 1. This we used to call as neta 3 and this we used to call as neta 2. Let's not write down medium 1 and medium 2 because you will be getting confused. For medium 2 I am calling neta 3. For medium 3 I am calling neta 2. So you will be getting confused there. So I have removed medium 1, medium 2, medium 3. So this I am calling as neta 1, neta 2 and this I am calling as neta 3. So what will be my neta in 1? Z0 square by ZL. So neta 3 square by neta 2. Now what will be your neta 3 square? This is your neta 3 square. What will be neta 3 square? So what will be neta 3? 120 pi divided by under root epsilon r, right? If you remember the formula of neta, what is neta? 120 pi under root mu r epsilon r. In 99% of the cases, mu r will be 1. So what will be the neta? 120 pi divided by under root epsilon r. This is for this formula is applicable for lossless dielectric, and 100% chances are there that if they are asking these kind of questions, they will give by default lossless dielectric only. And even if it is not mentioned, you will consider lossless dielectric only. What do you mean by lossless dielectric? Sigma is 0. I am just revising all the concepts so that you remember all the concepts that you have done previously. All these analyses are not required for solving this question. So for solving this question, what is required? You need the value of neta 3. So neta 3 will be 120 pi divided by under root 9 whole square divided by 120 pi under root 16. So what you are getting here, 120 pi will be left divided by 9 and here 120 pi will be gone divided by 4. So you are getting 4 by 9 basically. 120 by 9 into 4 by 9. This is the value of neta in we are getting. So now what I need to find? Gamma 1, 2. So what is my neta in? 120 pi into 4 by 9 minus, what will be your gamma 1, 2 actually? Neta in 1 minus neta 1 divided by neta in 1 plus neta 1. So this value you have already got, 120 pi into 4 by 9 minus 120 pi divided by epsilon r, that is under root 4. What I am doing is here is that what will be my this formula? That would be neta in 1 minus neta 1 divided by neta in 1 plus neta 1. Say yes or no. Just see the circuit and solve it. Just see the, sorry, not circuit, just see the orientation and solve it. What we need? Neta in from here. Then what we need to find? Reflection coefficient. So neta in 1 minus neta 1 divided by neta in 1 plus neta 1. So neta in 1 I have found out. How did I find it out? What is the length? Very important thing. Length is 3 lambda by 4. What is this? Odd multiple of lambda by 4. That means what will be my neta in 1? That would be Z0 square by ZL. So neta 3 square divided by neta 2. What is neta 3 square? That I can write down using this formula. That is 120 pi divided by under root epsilon r. So this I am getting, and then from here I am getting this one. So 120 pi into 4 by 9. So 120 pi into 4 by 9, and here what will be my neta 1? My neta 1 will be 120 pi divided by under root 4. So this is what I am getting. And here I need to just add them up. Four by 9 minus 1 by 2 divided by 4 by 9 plus 1 by 2. So 18 8 minus 9, 8 plus 9 by 18, minus 1 by 17. What is the answer? 1 by 17. So that is coming out to be minus 0.058. So this is the answer for gamma 1 2. Okay, this is your gamma 1 2. What about gamma 2 1? So gamma 2 1 I need to find. So for that, what do I require? Neta in 2 minus neta 3 divided by neta in 2 plus neta 3. Why is that so? Because how my wave is going? In this manner my wave is going. So looking from here, how much intrinsic impedance I can see? That is neta in 2. And what is the intrinsic impedance of my medium? That is neta 2. Why I have written neta 3 here? That is neta 2. So the intrinsic impedance of this particular medium is neta 2. Of this medium is neta 2. Okay. So this I need to find. So what will be your neta in 2 first? My neta in 2. That would be Z0 square by ZL. That is neta 3 square divided by ZL. What is ZL? ZL is neta 1. So what is neta 3 square? That is 120 pi into 120 pi divided by 9. And what is neta 1? Neta 1 is 120 pi divided by 2. Because under root epsilon r is 4. So under root 4 is 2. So from here what you are getting? 120 pi into 2 by 9. So here if you put the formula, if you put the values in formula, neta 2 1, what you are getting? 120 pi into 2 by 9 minus 120 pi into, what is neta 2 here? Neta 2 is 120 pi divided by 4, right? 120 pi divided by 1 upon under root 16 you can write down as of now. That would be 120 pi into 2 by 9 minus 120 pi, sorry, plus divided by under root 16. What you are getting? 2 by 9 minus 1 by 4 divided by 299, 2 by 9 plus 1 by 4. This is 36. 8 minus 9 divided by 36. 8 plus 9. What you are getting? Minus 1 by 17 again. That means what is your neta 2, gamma 2 1? That is again minus 1 by 17. Here also minus 1 by 17. So again you are getting minus 0.058. So in both of the cases you are getting the same answer. Okay. This is your neta 2 1. And what was your neta 1 2? That was also this value only. So this is how we can solve these kind of problems. Okay. Let's see more concept regarding this. That is intrinsic impedance matching. That means what is my target? My target should be whatever the wave that is coming, all should be transmitted. Whatever the wave that is coming, all should be transmitted. So that means what do I need? My reflection coefficient. What is my reflection coefficient for this case? This case we have already studied in EM wave only. What was the case? Neta 2 minus neta 1 upon neta 2 plus neta 1. If neta 1 is not equals to neta, if neta 2 is not equals to neta 1, then what will happen? Your reflection coefficient will not be equals to 0. So that means reflection exists. For 0 reflections, what do you need? For 0 reflection, what do you need? The reflection coefficient should be equals to 0. That means neta 2 should be equals to neta 1. This is what I need. But what happened in my case is that there is like medium is not in my control, right? If there is a boundary in between, this is air and here it is water. I cannot control the medium. If it is water, it will be water only. If it is air, it will be air only. But what I can do is that I can introduce another medium in between of length L. Of length L, another medium I can introduce in between. Then what I can do, what will happen here is that from looking from here, previously looking from here, what I was seeing? Neta 2. Looking from here, what I was seeing? Neta 2. Previously, in previous case, when I did not introduce any other material. So looking from here, I was seeing neta 2. But now what I have done is that I have introduced another material. If I have introduced another material, then looking from here, what I will see now? Neta in. What I will see? Neta in. Now, anyhow, the medium that I want to introduce, that is in my control. So that means neta in value is in my control. Neta in value is in my control. So I will set up the medium in a manner that neta in value becomes equals to neta 1. And if that is equal, then what will happen? Whatever the wave that is coming from here, after this medium, again, all the wave will be transmitted. Are you getting this point or not? Previously here neta 1 was not equals to neta 2. So that means this is not in my control. If this is air and this is water, then it will be air only, this will be water only. But now what I can do is that I can introduce another material in between. So looking from here, now I will see neta in, and that neta in I want to equate to neta 1. So this will be my target. And what kind of length I am going to use? I am going to use the length equals to the odd multiple of lambda by 4. Do you remember the concept of impedance matching in transmission line? Impedance matching in transmission line. What we used to do? This was your Z0, this was your ZL. So if Z0 was not equals to ZL, what we used to do? We used to introduce another transmission line. Here we introduce another transmission line, and then I used to connect this ZL here. This was having some Z0 dash impedance. So looking from here, how much impedance you would get? If this the transmission line is lambda by 4, then the impedance you would have got is Z0 square divided by ZL. And I used to equate this impedance to Z0. So I would set up the value of Z0 1 in a manner that this equation becomes true. Because Z0 1 is in my control. ZL, this is not in my control. Z0, this is not in my control. But Z0 dash value is in my control. So similarly here as well, I will set up the medium in a manner that my neta 3, I will set up the value of neta 3 in a manner that which equation becomes correct. So that we need to see. So what equation we will get now? So let's check that out. So if the length is odd multiple of lambda by 4, then what will be the value of neta in you will get? That would be Z0 square by ZL. That means neta 3 square divided by neta 2. And for zero reflections, what do you need? That your neta in should be equals to neta 1. Say yes or no. And from here what you are getting? Neta 3 square divided by neta 2 should be equals to neta 1. So from here neta 3 equals to neta 1 under root neta 1 into neta 2. This is what you are getting. So that means the intrinsic impedance of medium 3 should be the geometric mean of intrinsic impedance of medium 1 and medium 2. In the previous case, what we were getting? Z0 dash should be equals to Z0 into ZL. Say yes or no. Z0 dash should be equals to Z0 into ZL. In transmission line, this is what we are getting. Or we used to write it as Z0 1 into Z0 2. Because we used to match two transmission line there. Here what we are doing? We are matching two medium. But in between, I am introducing another material. So whatever the wave that is coming from here, the complete wave should be transmitted here. This is my target. So for achieving this target, what did I get to know is that the intrinsic impedance of medium in between medium should be equals to the geometric mean of intrinsic medium of the intrinsic impedance of the medium 3 should be equals to the geometric mean of intrinsic impedance of medium 1 and intrinsic impedance of medium 2. Is it easy to remember? Yes, very easy to remember. The new medium that you are introducing, this is how you will introduce. Say yes or no, right? Now let's check out one thing. So what we are getting? Neta 3 is equals to under root neta 1 neta 2. So what is neta 3? Can I write it down in this manner? 120 pi divided by under root epsilon r3. Say yes or no. Is equals to under root 120 pi under root epsilon r1 into 120 pi under root epsilon r2. Do you agree to this point? Certainly you agree, right? So what you are getting? 120 pi divided by under root epsilon 3 is equals to 120 pi whole square. So 120 pi divided by under root epsilon r1 into under root epsilon r2. So 120 pi and 120 pi is getting cancelled. Under root is getting cancelled. So what you are getting? Epsilon r3 is equals to under root epsilon r1 into epsilon r2. Say yes or no. Another formula you get. The relative permittivity of the medium that you are introducing should be equals to the geometric mean of relative permittivity of medium 1 and relative permittivity of medium 2. I hope you got how, I hope you understood how we are getting this formula. 120 pi and 120 pi is getting cancelled. This under root and under root is getting cancelled. Already there is under root inside. So epsilon R3 should be equal to under root epsilon R1 into epsilon R2. So formula goes same for the intrinsic impedance and also for the relative permittivity as well. Will you be able to remember this thing? A very, very important thing, that how we are doing the impedance matching, you can see, or you want to achieve zero reflections, the complete transmission you require. So this is how you can set it up. Is that clear to you? A very good point, a very good setup as well, and you are able to understand the concept as well. And the length should be the odd multiple of lambda by 4. But is it correct? Should I write down lambda by 4 or should I write down odd multiple of 2n plus 1 lambda 3 by 4? This is better because this medium will have its own lambda, this medium will have its own lambda, and this medium will have its own lambda. So length is set up for this medium. So lambda will also come for this medium only. And you can remember it with the concept of a transmission line. If you write down Z0 for this one, that means for this medium you are writing down the Z0. So similarly here, if I am writing down the lambda 3 or neta 3, that means for that particular medium I am writing down the lambda value. This is very, very important. Student oftenly they study this concept, but they miss this particular concept. That which lambda you need to take. 3 mediums are there, no, 1, 2, 3. Which lambda you need to take? So the lambda of medium 3 you need to take. Let's start solving the question. Find the value of epsilon R1 for zero reflection. What do you think? What will be the answer? Epsilon R1 should be equals to under root. Other two medium is epsilon R0 into epsilon R. The middle one will be the geometric mean of this and this. So under root 4. So from here what you are getting? Epsilon R1 is equals to 2. Another thing you need to notice here is that this length should be the odd multiple of lambda by 4. This length should be odd multiple of lambda by 4. Then only this formula is applicable. And 100% chance is there that if they are asking question on this particular concept, then this will be lambda by 4. Or it could be lambda by 2 as well. Because in lambda by 2, what will happen? Neta 2 will be equals to neta naught. So that kind of questions also you can see. The concept should be clear in your mind. The concept is, from here I need to see the equivalent neta. This is the concept. And when I see the equivalent neta, I can find the reflection coefficient. And if I am able to find the reflection coefficient, then I can do everything. Say yes or no. Okay. Someone is calling. Yeah. So this question was asked in GATE 123. Okay. This was asked in GATE 123. So try solving this question. A transparent dielectric coating is applied to glass. So there was a glass medium. There was a medium of glass. So this was glass. This was having an epsilon R value of 4. Now what you are doing? You are applying a dielectric coating on the glass to eliminate the reflection of red light. That means you are applying some coating here. Some coating you have applied. Some dielectric medium is there that you don't know which dielectric medium you used. So some coating you have applied. So there was a glass. On this glass you have applied some coating. And from here red light was coming. From here red light was coming. So from this particular medium, which would be, this medium would be air only. They did not mention any medium. So from here, from this air, red light was coming, which was having a lambda naught of 0.75 micrometer. So what will be the epsilon R naught? That will be 1 only. For air, what is the value of epsilon R naught? 0.75 micrometer. Now what is your target? Whatever the wave that is coming, whatever the light wave that is coming, the complete light wave should be going inside. This is your target. So what they are saying, the minimum thickness of the dielectric coating in micrometer can be used is. So if I call it medium 3, if I call this as medium 3, so what should be the length? What you are doing here, you are doing intrinsic matching only. What do you need? You need reflection coefficient to be 0. That means if I see neta in from here, if I see neta in from here, if I see neta in from here, that means I need neta in to be equals to neta 0. This is your air. If it is having neta 0, so neta in should be equals to neta 0. So you are doing what you are doing. You are doing the reflection, sorry, not reflection matching. You are doing the intrinsic impedance matching. And for intrinsic impedance matching, what kind of length you are going to use? Lambda by 4. But lambda of what? Lambda of this medium. So lambda 3 by 4. So now our target is to find lambda 3. What we have? Lambda naught we have. What is the value of lambda naught you are having? 0.75 micrometer. What I need to find? lambda 3. If I am able to find lambda 3, my job is done. Can you find the reflection coefficient of medium 3? What will be the, not reflection coefficient, what will be the relative permittivity of medium 3? That would be equals to under root 4 into 1. So this relative permittivity will be 2. Now what is lambda? Lambda is 2 pi by beta. What is beta? Omega under root omega by c under root mu r epsilon r, right? This is your lambda, right? Lambda is 2 pi by beta and beta is omega by c under root mu r epsilon r. That means your lambda is inversely proportional to under root epsilon r, because omega, it will never change, c never changes, mu r is always 1, 2 pi never changes. So your lambda is inversely proportional to under root epsilon r. Say yes or no? Did you get this concept? So now if I need to find lambda 3 divided by lambda naught, that would be equals to under root epsilon r2 under root epsilon r3. Say yes or no? So from here, my lambda 3 would be equals to lambda naught upon under root epsilon r3. So what that would be? 0.75 micrometer divided by under root 2, right? Under root 2. And what will be the length required? That is lambda 3 by 4. So the answer will be 0.75 micrometer divided by 4 into under root 2. Okay, so what is the answer you will get? They are 0.132. It was an easy question if you have studied the concept, but if you did not study the concept, then it would be tough for you, right? But this concept was introduced, I guess, for the first time in the examination. So a lot of guys were not able to solve this particular question, but it was very easy. Just the thing is, it was based on impedance matching, or you can say intrinsic impedance matching. So my target was to match the intrinsic impedance. And how did I achieve that? I need to use a length of lambda by 4, odd multiple of lambda by 4. Why I did not use 3 lambda by 4? If I had used 3 lambda by 4, then also the answer would be same. But what they are asking? The minimum thickness they are asking. What they are asking? They are asking the minimum thickness. So this was having another intrinsic impedance. This was having another intrinsic impedance. We need to match it. And when we match it, for matching, this is the condition. What is the condition? This is the condition we get for matching. For matching. So for matching, if we get this condition, then from here you can find the value of epsilon r3. If you are having the value of epsilon r3, you can get the value of lambda 3 by 4. That is the answer you require. So lambda 3 by 4, this is the answer. So now you would be able to solve any concept that is related to this particular concept. Okay. So now more miscellaneous concept we will see. So this is one of the concepts that we have seen in the beginning of this particular lecture. We started with this particular concept where we studied about the value of L and C for coaxial line. Now we will see more concept. Let's see what we need to see next. We will be studying about microstrip line, I guess. Yeah, microstrip transmission line. So in GATE 2016, one question has been asked. Until this point, I think that question is wrong. Okay, this question has been asked in GATE 2016. So for this particular question, we need to study this concept. And this concept is mentioned in Sadiku. That's why they are asking. That's why they asked this particular concept. And again, about microstrip line, you can, in microstrip line, there is a concept of fringing. And this we study when we study about capacitance. And we study about capacitance in electrostats. And electrostats was mentioned during 2016 in your syllabus. So that's why this question came. Now, whether it is mentioned or not, no, it is not in your syllabus. For EC student, I am saying. Since it is not in your syllabus, there is a very rare chance that this kind of question can come. But still, it has been asked, and student would be solving PYQs, then they will face this question. So for that, we are going to study this concept. But now I am taking a break. You can also take a break, and then you can come back, and we will study about this very small concept, that is microstrip transmission line. After that, what we are going to see? After that, we are going to see power loss in conductor, and then we will talk about power loss in waveguide. Okay, attenuation in waveguide, or you can say power loss in waveguide. And then we will see some question on, this question was asked, some question on globe based question we will see. And a very interesting point I am going to tell here about GATE examination. About GATE examination, some interesting point I will tell here. And then we will see some questions on antenna. So in that manner, we are going to see our miscellaneous concepts. Okay. So let me take a break. You can also take a break and then come back. Thank you. Yeah, welcome back. So now we need to study about microstrip transmission line. This is the third topic of our miscellaneous concept. We have already seen two topics. So now this one question has been asked on this particular topic. That's why we are studying it. And I don't think in future any question can be asked. But still, when you solve the PYQs, you will see this kind of questions. So that's why we are going to discuss it. So, what kind of transmission line we have studied? Two wires, and in between there is a dielectric. So here what is the scene? There is a conducting ground. Ground is always a conductor, and then there is a dielectric, and after that there is a conducting plate. Conducting strip is there, which is having a width of W and a length of L. Conducting strip, dielectric, and the ground. Okay, and this dielectric is having epsilon naught and this dielectric is having mu and epsilon as its parameter. Right. Now there is something called fringing. What do you mean by fringing? That you don't need to care. Okay, you don't need to worry about what do you mean by fringing. That we don't need to study. But because of fringing, what happens? Let's just say the material that you are using, that is having a relative permittivity of 2. So because of fringing, the relative permittivity, the effective relative permittivity will decrease. It could be like somewhat around 1.8, or it could be anything. It depends on some parameters. So that parameter you don't need to worry about. What is fringing, that also you don't need to worry about. But because of fringing, what happens is that the effective relative permittivity gets decreases. So this is the only thing that you need to keep in mind in microstrip transmission line. Because of fringing, the effective relative permittivity epsilon effective is lesser than the relative permittivity epsilon r. Basically, the effective relative permittivity will get decreased than the actual relative permittivity. So this medium was having relative permittivity of 2, but effective relative permittivity will be 1.8. Now, do you know as a very simple concept of capacitance? How do you define a capacitance of two plates? Let's just say this is one plate. This is one plate, and this is another plate. The spacing between these two plates is D. This is having a surface area of A. This is also having a surface area of A. Cross section area you can say. So how will you write down the capacitance value? That would be epsilon. Whatever the medium that you are using, that will have some epsilon. This can have some mu as well, but epsilon and the common cross section area. Let's just say this was having a cross section area of 2A, or it was having a cross section area of 3A. So only the common cross section area you need to take. So what will be the common cross section area? That would be A. So epsilon A by D. This is what you write. Say yes or no. This is the value of capacitance. I hope this much basic you already know. If you know this much basics, then it would be okay for you. Now if I need to write down the capacitance value for this particular scenario, here if I need to write down the capacitance value, so what I will write? Epsilon. But instead of epsilon, what I will write here? Epsilon effective. Because I need to write down the effective epsilon value. Into A. What will be the A? A will be the common cross section area. The ground will have infinite cross section area. Like there is ground plane. So that will have a very large area, but there is a strip, no? So what will be the area of this strip? That will be W into L. Say yes or no? Because it is having a width of W and length of L. So what will be this area? Which area I am talking about? I am talking about this particular area. So this particular area is common with the ground as well. So that particular area I need to write down. So that is W into L. It is looking like epsilon. Sorry, this was looking like omega, but this is not omega. This is W into L divided by D. What is the spacing between them? That is H. So this is the capacitance value I can write down. Is that clear to you? Okay. Let's see the next question. In the examination, this question was asked, and I don't think this was correct from their side. I think this was wrong only from their side. So what they are asking the Z naught value. What they have seen is what they have said is that a lossless microstrip transmission line consists of a trace width of W. It is drawn over a practically infinite ground plane and is separated by a dielectric slab of thickness T and a relative permittivity epsilon R. The inductance per unit length is given, and the inductance per unit length and characteristics impedance of the line are L and Z naught. So L and Z naught respectively. So what kind of relation is satisfied? This is what they are asking. So what is our Z naught? Z naught is under root L by C, right? So what is this L? L is the inductance per unit length. Say yes or no? Per unit length. And what is C? C is also capacitance per unit length. Capacitance per unit length. So now L is L only. You can see in the option L is written as L only. But let's write down capacitance. But we need to write down capacitance per unit length. What is the capacitance we know? What capacitance we know? That is equals to epsilon effective into A. What is A? W into length L. What is A? A is W into length L. This is the width and this is the length. So W into length L divided by the separation between them. What is the separation here? Here the separation is T. Separation is T here, right? Here I am assuming that length is L. What I am assuming? Length is L here. This is what I am assuming. This length is not shown, but I am assuming that this length is L. This is what I am assuming. Although it will not be used, because what we need to write down? We need to write down capacitance per unit length. This is the total capacitance. This is not the capacitance per unit length. So what is the separation between them? The separation is T. What I need to write down? I need to write down capacitance per unit length. What is this? This is your capacitance per unit length. So here can I write down it C dash? This is my C dash. Now C dash L is equals to C. C dash divided by L is equals to C, because what I need to write down? I need to write down capacitance per unit length. So that would be equals to epsilon effective into W by T. Say yes or no. Now what will be your Z naught? Z naught will be under root L by C. What is L? Epsilon effective. What could be epsilon effective? Epsilon effective would be epsilon R effective. Epsilon R effective into epsilon naught. Epsilon R effective into epsilon naught into W by T. So this is your Z naught. Now you need to compare it with this quantity, that is LT divided by epsilon naught epsilon R W. You need to compare it with under root LT divided by epsilon R epsilon naught W. So now you let me know one thing. What did I teach you? Because of fringing, what happens? Epsilon R effective is lesser than epsilon R. So this quantity is lower. This quantity is lower. This epsilon R effective is lower. That means this Z naught will be larger, no? Z naught will increase or decrease. If I had used simple epsilon R, if I had used simple epsilon R, that means I would be putting here 2. I am assuming my simple epsilon R is 2. But if I see epsilon effective, then what happens? This becomes 1.8. So that means Z naught will increase or decrease? It will increase, right? So my Z naught will increase. So as per me, what should have been the answer? As per me, the answer would have been that Z naught should be greater than L into T epsilon R epsilon naught W. Because from this particular relation, what do I get? From this particular relation, I get that under root LT epsilon R effective epsilon naught into W is greater than under root LT epsilon R epsilon naught W. The reason is, if effective is lesser, then this quantity will be larger, and that is equals to Z naught. So for me, this is the answer, that Z naught should be greater than LT upon epsilon R epsilon naught W. But what was the answer given by them? The answer, as per me, this is the correct answer, but this was given by them. And till this date, I am not able to understand why this was the answer. Okay, I have checked a lot of textbook. In every textbook, like, they are blindly solving it. Some guys are saying that they did not use this length, so you can assume this length equals to 1. This is what they are saying, that approximately W into L is taken as W. But no, there is no approximation here. Here we need to use capacitance per unit length. Like here in some of the solutions, like 2 to 3 books I checked in PYQ solution, because PYQ book, all the PYQ books are same. All the PYQ books are same. All have the same solution. Like I have seen a lot of mentors, like those guys who are having, forget about those mentors. So I have seen a lot of mentors comparing PYQ books. What is the meaning of comparing PYQ books? All the PYQ books are same. If someone is saying that this particular PYQ book is better, that means he is just promoting that book, nothing else. Because if someone is making a solution, everyone will be copying that solution in their PYQ book. You can pick 3 PYQ book and see the solution of one controversial question. Everywhere the same solution will be there. I can guarantee it. Because everyone is copying, right? So in all the PYQ books, what they have given is that W into L is approximately equals to W. Absolutely wrong. Doesn't make any sense. Because here they are using capacitance per unit length. So there is no approximation here. The doubt is this thing. This is the doubt here. As per me, this should be Z naught. that this equation A should be satisfied, the option A should be satisfied. But this is the answer given in the book as well. There is no satisfactory explanation. They are saying that okay, this value is larger, so this is my Z naught. So they are just somehow they are just saying that Z naught is lesser than. So there is no satisfactory explanation. As per me, option A should be correct. But answer given by them, answer given by ISC Bangalore was B. So if you are someone who has like some other opinion, then you can message me. I will certainly look into it. But as per me, answer A is correct. Okay. Rest I am not sure why this answer B was given. And according to the logic as well, this should be correct. But this was given. Here I am saying that given answer. Given answer, but according to me, this was correct. Okay. So L into C. So basically, capacitance value is getting decreased. If capacitance value gets decreases, that means Z naught should increase. But that was the answer given, so we cannot do anything about it. So that's it. That's it about microstrip transmission line. I don't think any other question can be asked on this particular topic. That was the only one question that they could have framed, and they asked it. Okay. Yeah. Let's go to the next concept. Now we need to study about the power loss in conductor. So when there is a power loss, when you will have a power loss, if there is a current, if there is current, and if there is some resistor, because what does the resistor do? Resistor dissipates the power. Resistor dissipates the power. So if there is a current and if there is a resistor, certainly there will be a power loss. Now what is the intrinsic impedance of a conductor? That is J omega mu upon sigma. I am writing J omega mu upon sigma. Omega you know, mu you know, what is sigma? Sigma is the conductivity. And for a perfect conductor, what is sigma? Infinity. So for a perfect conductor, what is the intrinsic impedance? 0. So there is no impedance. For a perfect conductor, there is no impedance, so certainly there will be no loss. In the conductor, this is a conducting plate having a width of W and length of B. Whatever the width we can take, let's just say this width I am taking as A and this length I am taking as B. So this is a conductor. It will have some current. We have connected this conductor to a circuit. We have connected this conductor to a circuit. So it will have some current. It is having some current like this. But there is no impedance. Why is that so? Because conductivity is infinity. If conductivity is infinity, that means intrinsic impedance of conductor is 0. So that means there is no loss. So this is the ideal condition, that if your conductivity is infinity, there will be no loss in the conductor. But if conductivity is finite, for a good conductor, what is the scene? The conductivity is very large, but it is not equal to infinity. So if conductivity is finite, then what will be intrinsic impedance? That would be J omega mu upon sigma. Now this intrinsic impedance has another name that is known as surface impedance. So you need to remember this name. Okay. This intrinsic impedance has another name, and this is known as surface impedance. What it is known as? Surface impedance. So it is nothing but intrinsic impedance only. So the surface impedance can be written as J omega mu upon sigma. Can I write it down in this manner? J omega mu upon sigma a to the power j45. Right? Because this angle is 45 degree. So can I break it down in this manner? Oh, sorry. Why j omega mu I am writing? Omega mu upon sigma. This is the magnitude. Omega mu upon sigma is the magnitude, and under root j will have the angle of 45 degree. Right? Can I break it down in this manner? What is a to the power j45 degree? That would be equal to cos 45 plus j sin 45. Right? So what that would be equal to 1 by under root 2 plus j 1 by under root 2. So can I write it down in this manner? 1 plus j divided by under root 2. Say yes or no, right? In that manner I can break it down. So this is your surface impedance. So your surface impedance is coming out to be 1 by under root 2 I am multiplying. So what I am getting? Omega mu upon 2 sigma plus j omega mu upon 2 sigma. So this surface impedance is having two parts. This is the resistive part. Resistive part, and this is the reactive part, right? Who will be responsible for power loss? Who will be responsible for the power loss? Resistive part, right? Because I told you the power is dissipated in the resistor, and in the capacitance and inductors power are stored. So power is dissipated in the resistor. So who will be responsible for the power dissipation or power loss? The resistive part, and this is the reactive part. So surface, this was your surface impedance. This is your surface impedance. But if they ask you what is the surface resistance, then you will write down omega mu upon 2 sigma. So this is also a very famous and very important formula. Like it may happen is that they will give you the value of omega, they will give you the value of mu, and they will give you the conductivity, and they will ask you what is the surface resistance of the conductor. So this kind of questions can also come. So this is one of the formula that you need to keep in mind. But is it something new that you are learning? No, this is something that you already know. What you already know, that what is the intrinsic impedance, j omega mu upon sigma, and that is equals to the surface resistance. Now I need to take the real part of it. So what I will do, j omega mu upon 2 sigma. So this is the resistive part, and same capacitive part is also, sorry, inductive part you can say, or reactive part you can say. Reactive part is also the same. Just take the under root 2 of it, j omega mu upon sigma. So what I am doing, just taking the under root 2. That's it. So this is the resistive part. So if I am asking you what is the value of surface resistance for a conductor, will you be able to write down? Yes, very quickly you will be able to write down what is the value of surface resistance for a conductor, omega mu upon 2 sigma. That's it. Is that easy for you? Certainly it is easy for you. And there are other formulas as well, like what is the formula of alpha? If you remember, omega mu sigma by 2. And what is your skin depth? That is 2 omega mu sigma. So actually you can relate both of them, I guess. Like some formula you can get, if you multiply both of them, what you are getting. So omega mu get cancelled, 2 and 2 get cancelled. So look, omega mu get cancelled. So I guess we are getting 1 upon sigma, right? If you multiply Rs into skin depth, Rs into skin depth. So what we are getting? Omega mu and omega mu will get, and under root 2 will get cancelled, right? So we are getting 1 upon sigma. So in the examination, these kind of questions they can frame. Okay. So this is just like, you don't need to remember it. You just need to remember the formula of Rs. You need to remember the formula of skin depth. In the examination, you will be able to solve it, right? So these kind of questions can come. Now, what you got to know, that you are having a conductor which will certainly have some current. It will certainly have some current. It is having some resistive part as well. That means certainly there will be power loss. In this case, there was no power loss because my sigma was infinity. So my surface resistance was 0 there. Neither resistance was there, neither reactive part was there. So if there is no resistance, no matter how much power it is having, there will be no power loss. But now it is having a surface resistance. It is having a resistive part, that is omega mu upon 2 sigma, under root omega mu upon 2 sigma. And because of that, there will be some power loss, right? And that power loss we need to write down. So what would be that power loss? Power loss is half I square into R. But here we will write down it here we will write down the power in terms of surface current density. So do you remember what is surface current density? Surface current density is Js here, and that will have a unit of ampere per meter square or meter? Ampere per meter. Volume current density has a unit of ampere per meter square, but surface current density has a unit of ampere per meter. I hope you remember this concept. When you were studying about Maxwell's equation, there I told you about this concept, that surface current has a unit of ampere per meter. So here the surface current is Js, and that is ampere per meter. So what will be the power loss? Surface resistance is Rs only. So what will be the power loss? So this kind of questions they can ask. The power loss will be 1 by 2 Js square mod of Js square into Rs. This is how we write down the power loss. Peak value into R divided by 2, right? Because here RMS should be coming, I RMS square into R divided by 2. But you let me know one thing, is it power or power density? Is it power or power density? It is power density. Why is that so? Because 1 by 2. What is the unit of this one? Ampere per meter. And if you take the square, ampere per meter square. And what is Rs? Ohm. So what is ampere square into ohm? That is watt per meter square. So what is this? This is power density. This is your power loss per unit area. This is power loss per unit area. This is power loss per unit area. Yeah, sorry for the interruption. So what I was saying, this is the power loss per unit area. This is not the power loss, it is power loss per unit area, because it has the unit of watt per meter square. And if you need to find the total power loss, then what will be the total power loss? Since you know the power loss per unit area, so you need to multiply with respect to area. So what we will do the integration, taking the limit of x from 0 to a and taking the limit of y from 0 to b. Or you can take limit of y from 0 to a, x from 0 to b. Basically, you need to integrate with respect to the complete area. So whatever the area that would be given, whatever the surface that is given, there you need to integrate, right? So this is the watt per meter square into dx dy. So this will be the total power loss in the conductor. Now what we need to study about. So let's see the summary of the discussion. So what is the summary? The summary is like I am having a conductor where some current is flowing. Now if the conductor is having conductivity of infinity, that means there is no surface resistance. If there is no surface resistance, that means there is no power loss. But if conductivity is finite, if there is a finite conductivity, that means it will have a finite intrinsic impedance, and intrinsic impedance is known as surface impedance only. Now in surface impedance there will be resistive part, there will be reactive part. But what is the matter of concern? The matter of concern is the resistive part. What is the resistive part? That is under root omega mu upon 2 sigma. You can relate it with the skin depth as well. But that is if you need to relate it with the skin depth, if the data of conductivity and skin depth is given, then you can find the surface resistance as well. So if you have the surface resistance, if you are having a surface current as well, that means certainly there will be a power loss. What that power loss would be? 1 by 2 mod of J square into Rs. So that would be the power loss per unit surface area. And if you need to find the complete power loss, then you will just integrate with respect to the surface. That's it. Okay. So this is the summary. Like within 1 minute you will be able to revise it. Now we need to see power loss or attenuation in waveguide. So if you remember the first slide of waveguide, when we started studying about waveguide, so first what did I teach you? I taught you about the structure of waveguide. So here there is conducting plate, two conducting plates are there, and from upward downward there are two conducting plates, and from here EM wave will enter, and it will get out from here, right? So this is a guided propagation of EM wave. But at that time, what did I tell you? That your conductor is having a conductivity of infinity, and the dielectric that you are using between the plates of capacitor, between the plates of conducting plate, the dielectric that you are using, that is having zero conductivity. If you remember this slide, right? Here we said that the dielectric is lossless dielectric and the conductor is having infinite conductivity. Now what if the conductivity is not infinite? Now what if the dielectric is not equals to 0? That means this could be a lossy dielectric and the conductor would not be a perfect conductor, but it is a good conductor. So if it is a good conductor, if it is having if it is having a finite conductivity, that means it will have some Rs, and if it is having some Rs, that means it will have some power loss. So there could be power loss in the conductors. That means there could be some power loss in the walls of waveguide. What is this? These are the walls of waveguide, right? These are the walls of waveguide. Here also there is a wall, downward as well there is a wall. So these are the walls of waveguide. So if the conductivity of the conductor is finite, then there will be some surface resistance, and because of that surface resistance, there will be some power loss in the walls of waveguide. Do you agree to this point? Yes. Now what could be the second power loss? The second power loss will be because of this dielectric. If the dielectric is lossless, that means if sigma is 0. So if sigma is 0, there is no power loss in that dielectric. Okay, if conductivity is 0, that means this is lossless dielectric. If the dielectric is lossless, that means there will be no loss. But if conductivity is non-zero, that means in the dielectric as well there will be losses. So there can be two kind of losses. If it is a lossy dielectric, or I am writing low loss dielectric. The dielectric is lossy, but the loss is very small. But still there is loss, no? That means conductivity is not equals to 0. And here I am not writing it perfect conductor. I am writing it as a good conductor. If it is a good conductor, that means certainly the conductivity will not be infinity. It would be pretty large, but it is not infinity. So because of this there will be power loss, and because of the lossy dielectric or low loss dielectric as well, there will be some power loss. So in the waveguide there are two factors which can result in power loss. And if you remember, what were the factors in transmission line for power loss? In transmission line there could be three kind of power loss. What kind of power loss? Because of the conductor, because of the dielectric, and because of the reflections. There could be three kind of power loss. Did we study this kind of phenomena in antenna? What we studied there? That this is my transmission line, and at the load of the transmission line you are having the antenna. Now if you are spending P in from here, what will be your P radiated? The P radiated will be neta into P in, and that is affected by three factors: reflection, dielectric in between, and resistance, radiation resistance, or you can say lossy resistance. Sorry, there would be three factors: lossy resistance and reflection coefficient. That lossy resistance can come into action because of two factors. What are the two factors? Because of the dielectric present and because of the conductivity of the conductor. But here what is the scene? Here there is no load. There is nothing like load. It is open till infinity. So there is nothing kind of load is there. But there are conductors as well and there is dielectric as well. If dielectric is lossy, that means because of the lossy dielectric there could be some losses. And if there is conductor who is having finite conductivity, then because of the conductor as well there will be some losses. Say yes or no. So these two losses we need to study. Are you getting this point? So we will study about those losses, but let's study something else. So what I am saying, that in the waveguide, the power that is going in, some EM wave would be coming, no? Some EM wave will have some power. This EM wave will have some power. So the power that is going in is P naught. So P naught is the power delivered to the waveguide. Now this power will travel inside the waveguide. This power will travel inside the waveguide. So now the power will be getting reduced. And how it will be getting reduced? P naught e to the power minus 2 alpha z, where alpha is the attenuation constant. And why this attenuation is coming? Attenuation constant. Why this attenuation is coming? It is coming because of the lossy dielectric and because of the conductor. Because conductor is not having infinite conductivity and your dielectric is not having zero conductivity. And because of that, this attenuation constant is coming. So power that came in was P naught. But if it travels a distance of z, then the power will be reducing by this factor, e to the power minus 2 alpha z. If you remember in EM wave, our peak value was E naught. But if it travels, then it reduces by the factor of e to the power minus alpha z. Really sorry, it reduces by the factor of e to the power minus alpha z. Right? If it is having some attenuation, if it is having some loss, that means your magnitude of E naught will reduce by a factor of e to the power minus alpha z. Say yes or no? And for the conductor, we find the skin depth, that at what value of z it becomes 1 by E. Right? These kind of concept we study in EM wave. But as of now, till now, what we were studying in waveguide, we were studying that if E naught is entering, then till the end as well there will be E naught only. But now what will happen? If E naught is entering, then it will lose its amplitude. And why is that so? Because of the loss. There is lossy dielectric and there is good conductor. Because of the loss, it is losing its amplitude. And how it is losing its amplitude? This is about power. This was about electric field. And if you talk about power, what will happen? E naught square by 2 neta. So instead of E naught square, what you will write down? E naught square e to the power minus 2 alpha z. And I am writing this as P naught. So what you will get to know? P naught e to the power minus 2 alpha z. So power that entered was P naught, but it will reduce by the factor of e to the power minus 2 alpha z. Why 2 alpha z? Because this is power. Here it was alpha z. For electric field, it was alpha z. But when I convert it into power, then I need to do the square. So that's why e to the power minus 2 alpha z. So if power entering is P naught, then how the power will reduce? Okay, let's solve a question now. So let's solve this question. Power delivered to the waveguide is 1.2 kilowatt. So power that came in is 1.2 kilowatt. Attenuation constant is given 4.128 into 10 to the power minus 3 Nepper per meter. Find the power dissipated in the 60 centimeter length of the waveguide. You need to find the power dissipated. So what was the power that entered? That was 1.2 kilowatt. And at the distance z, how much power you will be left with? At distance z, how much power you will be left with? So if you walk like this was the initial power that entered. Now if I travel down, then it will reduce by e to the power minus 2 alpha z factor. So what was the power that entered? 1.2 kilowatt. E to the power minus 2 alpha value is given z. Now at what distance I need to find? At 60 centimeter. So at 60 centimeter, what will be my power? At 60 centimeter, my power will be 1.2 into 10 to the power 3 e to the power minus 2 alpha 4.218 into 10 to the power minus 3 into z. Z is 60 centimeter. So that is 0.6. So what will be the power at 60 centimeter? (4.218) into 0.6 divided by 1000 into 2 plus minus e to the power into 1.2. So power is coming out to be 1.1939 10 to the power 3 watt. So the power entered was 1.2 kilowatt. Now this much power is remaining. So where has the power gone? So power was dissipated, right? So what will be the power dissipated? So power dissipated. What will be the power dissipated? So power that was entered 1.2 into 10 to the power 3. But how much power is remaining? This much power is remaining. So what is the power that is dissipated? So just subtract 1.2 into, so 6 watt power, roughly around 6 watt. So what you are getting? So 6 watt power is dissipated. So what did I do? Whatever the power that entered, then at distance z, how much power I am having, and then subtract both of them. What you are getting? 6 watt power is dissipated in the waveguide, right? In the waveguide, 6 watt power is dissipated, and rest of the power is transmitted. Okay, in 60 centimeter. In that manner, you can solve this question. Now let's talk about the attenuation constant more. Okay, so our attenuation will be because of two factors: conducting walls and the medium. So cause of attenuation will be 2. This is because of dielectric. Okay, because dielectric is not having sigma equals to 0, and this is because of the conductor. This is because of the conductor, because it is not having sigma equals to infinity. So total attenuation will be alpha equals to alpha c plus alpha d, right? So for lossy dielectric, or I am saying for lossless dielectric, if you remember the value of alpha, do you remember the value of alpha? For low loss dielectric, in EM wave we studied this formula. If you remember, that was sigma by 2 under root mu upon epsilon. Do you remember it? You can go to your EM wave chapter. There, before starting the assignments, I have taught this formula. Before the starting of assignment, I have taught this formula. Alpha is equals to sigma by 2 under root mu by epsilon. For low loss dielectric. This is not for lossy dielectric. This is not for lossless dielectric. For lossless dielectric, alpha is 0. That means there is no attenuation. But for lossy dielectric, alpha is sigma by 2 under root mu by epsilon. Can I write it down in this manner? Sigma by 2 into intrinsic impedance, because what is intrinsic impedance? That is under root mu by epsilon only. So for lossy dielectric, the attenuation constant is alpha d, that is sigma by 2 into neta. Sigma by 2 into neta, but another factor will come into action, that is 1 minus fc by f whole square. But let me write it down in a good manner. So that is, here I will write down. So alpha d is equals to sigma by 2 into neta. So this was the formula for general case. Since it is a guided propagation, so in guided propagation another factor will come into action, that is under root 1 upon fc by f whole square. This factor is not new to you, right? This factor is already known to you. So this is your alpha d. Will you be able to remember this point? Attenuation constant because of the lossy dielectric, that would be sigma by 2 into neta. This is, we already remember. This is something that we already remember. Because of lossy dielectric or because of low loss dielectric, what is the attenuation? That is sigma by 2 into neta. But since we are studying for waveguide, then another factor will come into action, that is under root 1 minus f by fc whole square. Sorry, 1 minus fc by f whole square, right? And under root 1 minus fc by f whole square, that will come in that denominator. So this also you need to remember. It will not come into numerator, it will come into denominator. And it is applicable for both TE and TM modes. This is applicable for both TE and TM mode. Now some guys would be thinking that, sir, this formula must be there for TE mode, because in TE mode our intrinsic impedance is neta upon 1 minus fc by f. No. This formula has nothing to do with TE TM. The derivation of this formula is something different that we are not caring about. We are directly writing the formula. So this is applicable for both TE and TM. Here this neta has nothing to do with the TE or TM. This is a separate derivation. So don't think that, sir, for TE mode it is neta upon under root 1 minus fc by f square, and for TM mode it would be neta into 1 minus fc by f whole square. No. Nothing like that. This is formula that will be applicable for both TE and TM mode. Is that okay for you? Okay. So this is for the lossy dielectric. Now attenuation because of finite conductivity of the conductor. That means if sigma is not equals to infinity. So this formula is very complex. But if someone asks you in the statement that what will be the value of alpha c, then you can write down power loss per unit length, power loss per unit length divided by 2 into power carried by waveguide. Okay, if these data are mentioned, then you can use this formula, but there is very rare chance that they will ask any question on this formula. Okay, very rare chance. Till this date there has been no question on this particular topic, attenuation in waveguide, but in Shevgaonkar sir playlist, in the playlist by NPTEL, this topic has been mentioned. That's why we are studying it, and since it is not introduced and it can be introduced in the examination, that's why we are studying it. So mostly chances are there that they will ask this kind of question, that they will give the input power and at a distance they will ask the power, or they will see that at a particular distance how much power loss is there. This question is from Sadiku. Okay, this question is from Sadiku only. So this question they can ask. Or what kind of question they can ask? They can ask you the value of alpha d. Alpha d is coming into action because of a lossy dielectric. So this they can ask. Or they can ask you they will not even mention the value of alpha. Here I have mentioned the value of alpha, no? So they will not even mention the value of alpha. They will ask you to calculate the alpha. There they will give that the conductivity of the conducting walls is infinity. Conductivity is infinity of the conducting walls. That means there will be no loss because of the conductor. But the lossy dielectric is having some conductivity. It is having some finite conductivity. So all the factors will be coming because of sigma d. So only sigma d, sorry, all the attenuation will be coming because of the dielectric. So only alpha d will be in action. So your complete alpha will be equals to alpha d, and then they can ask you this analysis, or they can only ask you the value of alpha d as well. But there is very rare chance that they will ask you the value of alpha c. But even if they ask, you need to apply this formula: power loss per unit length in the waveguide divided by 2 into power carried by the waveguide. Is that okay for you? Will you be able to apply this formula? Certainly. Okay, but the formula is very complex, like it would be some, there would be 10 to 12 terms, so that formula will not be asked in your examination. But they can ask you this statement, or they will give you that power loss per unit length is somewhat this value, and this was the total power that was carried by the waveguide. Then they can ask you the value of alpha c. So this kind of question can come. And what will be the unit of this? Napier per meter. What will be the unit of this? That will also be Napier per meter. And what will be the total attenuation constant? That will be the addition of both of them, alpha c plus alpha d. Is that clear to you? Now what kind of questions can be coming? This kind of question can be coming. So what they are saying, copper plate waveguide is there, sigma value is 5.8 into 10 to the power 7, operating at 4.8 gigahertz, filled with polystyrene, sigma value is this much, and its dimension are this. Calculate alpha d, that means attenuation constant because of the dielectric. What they are asking? Dielectric attenuation constant. And that is equals to sigma by 2 into neta under root 1 minus fc by f whole square. Now you just let me know one thing, what value of sigma you will be using. Which sigma you will be using? There are two sigma, copper plate and polystyrene. Which sigma you will be using? This sigma. Why is that so? Because what they are asking? They are asking because of the dielectric. So sigma of dielectric you will use, no? You will not use the sigma of conductor. This is the sigma of conductor. You can see copper plate waveguide. So the plates are of copper, but the dielectric that is in between, that is having this much conductivity. So which sigma you will use? You will use sigma 10 to the power minus 17 Siemens per meter. Epsilon r value is given, dimensions are given, T10 mode is given. Try solving this question. You can do it on your own. Certainly you can do it on your own. I will take a pause. You can try solving this question. Yeah, so let's start now. What I need to find? Sigma I am having, neta I can find. First the task should be to find fc value. So what is my fc? Fc is Vp by 2a. Why is that so? Because mode is mentioned, that is TE10 mode. For TE10 mode, fc is Vp by 2a. What is my Vp? My Vp will be 3 into 10 to the power 8 but the medium is not air, the medium is having epsilon r of 2.55. So divided by 2.55 into 2 into a, what is a? 4.2 into 10 to the power minus 2. So this is what we are having. So you can solve it over 2.55 under root into 2 into 4.2, then reciprocal into 3. So this will be 2.23 gigahertz. 2.23 gigahertz, yes. So FC value I am having, and F value, what is the value of F? 4.8 gigahertz. This is the value of F, right? So this factor I can calculate sigma by 2. What is the value of neta? So since the given mode is TE10, so are you thinking that I should write neta TE here? Now this is simple neta. Which neta we are talking about here? This neta is the neta if there was no waveguide. If there was no waveguide and simple dielectric medium was given, then what would be the value of neta? Here this neta is not neta guided. Now here I need to write this neta, important point, that neta is not equal to neta guided. This is simple neta. I hope you know what is neta guided. Neta guided is like for TE mode it is different, for TM mode it is different, but this is the simple neta. Simple neta means if there were no conducting walls, if there was no waveguide, if there was only this medium, then how my wave would be propagating? In that wave, what will be the value of intrinsic impedance? That is this neta. So here I am not going to apply for this neta, I am not going to apply any formula that neta divided by under root 1 minus fc by. Now this is simple neta. Are you getting this point? Say yes or no. So this is the simple neta here. Don't think that it is for TE mode or TM mode. No, nothing like that. Okay, so this neta is not going to change. So what will be the value of neta here? So that was also a very good point which I should have explained here, because I know a lot of guys would have applied the formula of neta TE here, but that is something we do not need to apply. What they would have done is that neta upon under root 1 minus fc by f whole square. So under root 1 minus fc by f whole square into the same quantity. So this under root will be gone. So that would be wrong. This neta is the simple neta. This is not neta guided. Okay, so this is also a very important point. So what is neta here? That would be 120 pi divided by under root epsilon r. That is 120 pi divided by under root epsilon r. What is that? 2.55. So 2.55 under root reciprocal into 120 pi into pi. 236 here and here, yeah, 236.08 ohm. Okay, so what I need to find now I have all the values. So alpha d would be sigma. What is the value of sigma? 10 to the power minus 17 divided by 2 into, what is the value of neta? 236.08 divided by under root 1 minus, what is the value of fc? 2.23 divided by f, that is 4.8 whole square. This is the answer we will get. So 2.23 divided by 4.8 whole square minus 1 plus minus under root reciprocal into 236.08 divided by 2. So 133.29 into 10 to the power 17. Yeah. So 1.33 into 10 to the power minus 15 Nepper per meter. This is the answer. Okay. So certainly this kind of questions can be coming in your examination. So they can ask you the value of alpha d. They are not going to ask you the value of alpha c. They will say that alpha c is 0. If they want to proceed in this question, if they want to convert this particular problem into this problem, that they will give you the value of p naught, and they don't want to give you the value of alpha. So they will say that because of conductor alpha c is 0, but because of dielectric alpha d is that value that you need to find on your own, and then you need to find the power dissipated in 60 centimeter length. Or if they want you to find the value of alpha c, then they will give you these data. Power loss per unit length divided by 2 into power carried by the waveguide. Is that okay for you? All good? Okay, so this is the topic that is completed. Now some guys would be getting confused that when we are studying waveguide, what did I tell you? That either alpha will be there or beta will be there. Say yes or no. This is what I told you, that either alpha will be there or beta will be there. Both will not be there together. But that is true only when this sigma was 0 and conductivity was here infinity. That was the case when we were considering that there is no loss. Now this loss is coming into action. All these losses are coming into action when the wave is propagating. Here what did you see? That here Fc is greater than F. Here Fc is greater than F. So what you will say? If Fc is greater than F, that means beta g is there. If Fc is really sorry. Here what you can see is that F is greater than Fc. If F is greater than Fc, that means what you will say, that beta g is there. That means alpha g will not be there. Certainly alpha g will not be there. But this alpha is coming into action because of the losses. This is not alpha g. Are you getting this point? There are three kinds of alpha. Alpha because of dielectric, alpha because of conductor. And these two will come into action when actually the wave propagates. If the wave is propagating, then these guys are coming into action. Are you getting this point or not? Here what is my gamma? In this case, what is my gamma? Here in this case, my gamma is some alpha plus beta g, right? But what is the alpha here? Here alpha is alpha c plus alpha d. So in this case, in this particular case, better I should write here. In this particular case, my gamma is alpha c plus alpha d into j beta g. And at that time, my wave is propagating. This is the case of F greater than Fc, propagation mode. So if there is propagation, then there will be some attenuation. If your conductivity is not here, your conductivity is not 0, and here your conductivity is not infinity, then there will be some losses. These losses we talked about. But if there is no propagation, if there is not even propagation, if F is greater than Fc, then alpha g will be 0. What will be your beta g? That would be beta into under root 1 minus Fc by F whole square, right? And what will be your alpha at that time? That would be alpha c plus, so better writing down alpha g equals to 0. What I should write down? Here my alpha g would be equals to alpha c plus alpha d. But now if there is no propagation, at all, that means beta g cannot be possible. So what will be the value of alpha g? That would be beta into beta into Fc by F minus 1 whole square. Say yes or no. And what will be the beta here? Beta will be omega under root mu epsilon, or you can say omega by c under root mu r epsilon r. So this will be the formula of alpha g. This is the formula beta g that we already know. But if non-propagating mode, if we are talking about non-propagating mode, if there is propagation, then different attenuation constant will be there. If there is propagation, then losses could be there because of dielectric and the conducting plate. But if there is no propagation, that means if your F is less than Fc, that means it is non-propagating mode, then what will be the attenuation constant? Then this will be the attenuation constant, and that attenuation constant I am calling as guided attenuation constant. Are you getting this point or not? Previously I was saying alpha g and beta g cannot come together. Either alpha g would be there, or either beta g would be there, or alpha g would be there. But why here both are coming into action? Because previously we were not taking losses into action. We studied complete waveguide without taking losses into action. But now I am saying that if there are losses, then what will be the scene? So if there are losses because of the dielectric and because of the conductor, then there will be attenuation. And which attenuation will be there? Alpha c plus alpha d. And what about beta g? That we already know. Now if F is less than Fc, non-propagating mode, then what will be the value of alpha g? And how this formula came? That is very easy. How did we start the derivation? Gamma g square is equals to what? Kx square plus ky square minus omega square mu epsilon. From here we start the derivation, then we replace these values. From there Fc, omega c value we get, then omega c value we replace. Basically we replace this value as omega c square mu epsilon minus omega square mu epsilon. This is how we replace it. Then from there we say that gamma g will be equals to alpha g plus j beta g, and from there whether alpha g would come into action, beta g would come into action. If real part is there, that means alpha g would come into action. If imaginary part is there, that means beta g would come into action. So this is how we derive this formula. If you remember it, I hope you are remembering this particular formula. So this is how we derive it, and from there this formula we get. Now if your Fc is greater than F, if Fc is greater than F, then this quantity will be imaginary. If this is imaginary, that means total quantity will be real. So what did I just do? I just replaced Fc by F. Here Fc by F was here because this quantity was lesser than 1. But if this quantity is greater than 1, that means it is non-propagating mode. So this formula of alpha g you need to apply. Alpha g is equals to beta into under root Fc by F whole square minus 1. Let's apply this formula. I will just frame a question. What kind of question I will frame? That epsilon r is given, that is 9. Okay, epsilon r is given 9. A is given 2 centimeter. So here if I ask you what will be my Fc for TE10 mode, that would be Vp by 2a. So 3 into 10 to the power 8, 3 into 10 to the power 8 divided by under root 9 into 4 centimeter. So what you are getting? 1 by 4 into 10 to the power 10. So 2.5 gigahertz, right? So this is the Fc. Now I can give you the frequency that is given as 1 gigahertz. So if it is 1 gigahertz, this is given. Okay, right? Now you need to find what will be the value of guided attenuation. This is the question. So here we have found out that, and the mode is given, that is take TE10 mode. Take TE10 mode. Take TE10 mode. So your first task will be whether to find out it is propagating mode or not propagating mode. If it is a propagating mode, then this calculation you will do. If it is a propagating mode, here what did I get to know? That F is greater than Fc. That means it is a propagating mode. So now losses can come into action because of two things: dielectric and conducting plate. But now if it is not even propagating, then complete loss would be there. No, it will not even propagate. So after some distance it will be completely gone. So here the losses will be coming into action because of alpha g. Are you getting this point? Here the losses will be coming into action because of this one. Here forget about the conducting loss, forget about the dielectric loss. Here the wave is not even propagating. So complete loss will be there. Are you getting this point? Here there is no propagation. So here your Fc is 2.5 gigahertz. I hope I did the calculation correctly. So here if it is 9 10 to the power 8, 4 centimeter, 2a 4 centimeter. So 10 to the power 10, 10, 2.5. Yeah, 2.5 gigahertz. So here I can get to know that my Fc is less than, sorry, Fc is greater than F, which is greater than 1 gigahertz. That means no propagation. So if I need to find the value of alpha g, what that would be? Beta into under root Fc by F whole square minus 1. What is the value of beta? Omega by c under root epsilon r into under root Fc by F, Fc by S, that is 2.5 whole square minus 1. That is omega. What is the value of omega? Now value of omega will be 2 pi into 10 to the power 9 divided by 3 into 10 to the power 8. 2 pi f, 2 pi into 10 to the power 9 divided by 3 into 10 to the power 8 under root epsilon r, that would be 3 under root 9 under root 2.5 whole square minus 1. So this calculation I need to do now. So 3 and 3 is getting cancelled. Upside it is becoming 20 pi, right? 20 pi. Then 2.5 whole square, 2.5 whole square minus 1 under root into 20 into pi. So it is coming out to be 143.9 Nipper per meter. This is the answer here. This is the attenuation constant. Okay, you can see very high value it is coming. When I calculated alpha d 10 to the power minus 15, When I calculated in some of the question, alpha c was also given, like here attenuation was in some 10 to the power minus 3, but what you are getting here, very high attenuation, 143.9. That means it will be attenuated very fastly. Are you getting this point? Okay, so this is how we are going to solve it. Let's check back the calculation. 3 and 3 gets cancelled. 20 into pi under root 2.5 beta g. This formula we applied. fc by f 2.5 by 1. Yeah, calculation is also correct. So 143.9 per meter. So are you able to understand what all kind of attenuation would be there? Two kind of attenuation. If wave is propagating, if wave is not propagating, based on that you need to see the attenuation. So now the concept of attenuation is also clear. What I can expect is that in the future some question can be coming from this concept, because till now this concept has not been introduced in your examination. They never asked attenuation in waveguide. Whenever we study waveguide, by default they say that the medium is lossless and the plates are perfectly conducting. So if medium is lossless and plates are perfectly conducting, that means there will be no attenuation constant. But if these kind of known idealities are introduced, then these kind of attenuation can also be there. Okay, and this concept is also done now. Now what we need to study? We need to study about globe. So why we are studying about globe? That also I will tell you. And what all portion of globe you need to know, that also I will tell you, but after a break. So let me take a break, because I am getting tired very quickly nowadays. So first I will take a break and then we will study about globes. Okay. Yeah, welcome back. So now we will study about globe. Now the first question that would be coming into your mind would be that, sir, why do we need to study about globe? We are UPSC, we are not UPSC aspirant, we are students of GATE ECE or electrical. Why do we need to study about globe? So if you see GATE PYQs of aptitude, I'm not talking about EMFT. If you see the GATE PYQs of aptitude, there you will realize there are 3 to 4 questions which will require the knowledge of globe. Okay, 3 to 4 questions which will require the knowledge of globe. In aptitude I am saying. And I made PYQ solution of aptitude on this channel only, on PrepFusion only. Those solution I made in December 2023. In December 2023, I made those solutions. And at that time, I told all the students that if you are going for GATE examination, certainly you need to have a knowledge of globe. In December 2023, I said that, and this question was asked in GATE 2024. And to solve this question, you need to have a knowledge of globe. Otherwise, you will not be able to solve it. I don't know what is the reason behind it, but the paper setter always expect that GATE aspirant would be knowing about the globe, and especially in EC, because we have in EC we have spherical coordinate system in our syllabus, and we have vector calculus as well. So from spherical coordinate system they can ask question on globe as well, and this question is based on spherical coordinate system only. So certainly they can ask some question on globe. Are you getting this point? So we need to have good amount of knowledge about the globe. So whatever that is required, that I'm gonna tell. So I am having a globe. So this point is known as, I hope you know what is north, south, east, west. So this is your north, this is your south, this is here. What is West Bengal? Here where West Bengal is there, so this is known as east. Wherever in the map of India, if this is the map of India, so in the map of India, here you are having West Bengal. So this side is east actually. Why it is named as West Bengal? Because it is the west of Bangladesh. That's why it is known as West Bengal. Okay, West Bengal. That means west of Bangladesh. So this is east, this is west. So this is east and this is west. So this is how you can remember. Like people would be getting confused in east and west. So this is the manner I remember. Where there is West Bengal, at that side is east, and this is west. Okay. So now it starts from 90° north. So this globe starts from 90° north. So this point is 90° north. And now from 90° to you cover complete 0°. You start from here. You start from here 90°, 80° north, 70° north, and you go till 0° here. And downward you start from 90° south. This is your 90° south, the downward point, 90° south, and then you go upward 80°, 70°, 60°. You can see in this diagram. So the downward point is there, 90° south is there, and then you come back to 0°. Now right in the middle you draw a circle, right in the middle of the globe. This is the globe. Right in the middle of the globe you draw a circle. You draw a circle, and from that point you start 0°, and then you work. I am working from here, from 0°. I am working from here. So this is my 10° west. If I am working towards this direction, this is my 10° west. So I am working towards west now. And if I work here, so that would be my 10° east. Is that clear to you? So you need to remember this thing. I will start from 90° north. I will go till 0°, and then from 90° south, I will go till 0°. And from here I start. From here I start. So from 0° I start. This is your 0 degree. This is 0 degree only. North, west, nothing. It is 0 degree. It is this point. This point. It is this point, 0 degree. Now from here, if you start towards west, then 0 degree, 0 degree, then 10 degree west, 20 degree west. And if you go towards east, then 10 degree east, 20 degree east. In that manner, you proceed. So this is your complete globe. Is that okay for you? And till this point, it will go 0 degree till 90 degree. It is going here also till 90 degree, here also till 90 degree. Now here there are two kind of circle on this globe. There are two kind of circles. One circle is this one. Can you see it? Right? One circle, can you see it? Again, I am highlighting it with different color of pen. One kind of circle is this. Okay, cannot highlight with this. So here you can see one circle is this one. And another circle will be this one. Like it will be coming back and like this it will be coming back. You cannot see it in 3D, right? This and then it will be coming back like this. From here it is coming back. So this is one complete circle. So there are two kind of circles. So this circle which is horizontal, these horizontal circles are known as latitude circles. Latitude circles. And these vertical circles, these are known as, this I am showing, longitude circles. Longitude circle. So if I write down the summary in top level, what you need to remember, that this is peak 90 degree north. This is peak 90 degree south. This is also peak 90 degree west. And this is your 90 degree east. Okay, this is you need to remember. And there are two kind of circle. One circle you can directly see, and another circle is this one. Another circle is this one. So two kind of circles are there. What is this circle? This is known as your longitude circle. Longitude circle. And this is known as your latitude circle. So if you have this much knowledge about the globe, then you would be able to solve all the problems, whether it is aptitude PYQ or it is your EMFT PYQ. So if you are going in the gate examination, certainly you should have a knowledge of globe. So that knowledge I have given, whatever that is required. And this line is known as equator. Okay, the line which is cutting the globe into two parts, that is known as equator. The one which is cutting horizontally, that is known as equator. So this line is known as equator. And one line can cut the globe in two parts vertically as well. This line is cutting horizontally and one line can cut vertically as well. So that is known as meridian. So this line is known as meridian. Okay, if you want to remember, then you can remember equator and meridian. Okay, one which cut vertically, that is meridian. One which cut horizontally, that is equator. If you want to remember it, then you can remember. But longitude, latitude, and this 90 degree, that you need to know. Is that clear to you? All good? Let's start this question. Consider the Earth to be a perfect sphere of radius r. Okay, this is our Earth, perfect sphere of radius r. Then the surface area of the region enclosed by 60 degree latitude circle that contains North Pole in its interior is. What they are saying? The surface area of the region enclosed by 60 degree north latitude circle. Where is 60 degree north? Here is 60 degree north. Latitude circle. Which is the latitude circle? The horizontal one. This is the latitude circle. Latitude circle. This is the latitude circle they are talking about. This is the latitude circle they are talking about. 60 degree latitude circle. 60 degree latitude enclosed by 60 degree north latitude circle that contains the North Pole in its interior. Contains the North Pole in its interior. So this area they are talking about. Are you getting this point or not? Did you understand this point? What they are asking? They are asking about this area. 60 degree North Pole latitude circle. 60 degree North Pole, I should not say. 60 degree North latitude circle which is containing North Pole. Which is containing North Pole in its interior. It is containing North Pole in its interior. If they had said containing South Pole in its interior, that means they are asking about this area. If they had said that it is containing 60 degree north latitude circle, 60 degree north latitude circle Containing south pole, that means downward area they are talking about. Containing north pole, that means this area they are talking about. Are you getting this point? So, the teacher or the professor who framed this question, he framed it very, very nicely. He deserves appreciation for this particular question. Okay. 60° north latitude circle containing north pole. Are you able to visualize now? If you know this much of thing about globe, then you would be able to visualize it. 60° north latitude circle containing north pole. So this area they are talking about. Now we can find this area. How we can find this area? What we can do is that, let's just say this is our coordinate system. In our coordinate system, we are having the globe. This is how my globe is placed. How my globe is placed? This is how my globe is placed. Okay. So how much area I need to find? Somewhere there is 60°, right? Somewhere there is 60°. Somewhere there is 60°. This is your 60°. 60° north. 60° north latitude circle. So this much area I need to find. Say yes or no. So surface area I need to find. That means what is my surface? What is my surface here? R equals to constant. My surface is R equals to constant. Because if I am rubbing my hand here, that means it is R equals to constant surface. Here theta is changing, here phi is changing, but here R is constant. So what will be the surface area? Surface area will be in the direction of AR cap. And what will be the surface area? R square sin theta d theta d phi AR cap. That will be the surface area. But I don't need the direction, I only need the magnitude. So surface will be in the direction of AR cap because the equation of the surface is R equals to constant. That means this, we need to take the surface area in the direction of AR cap. So this is the surface area I need to take. So if I need to find total surface area, what I need to do? I need to integrate. So R square, the radius is capital R. So capital R square sin theta d theta d phi. So on this particular surface, what will happen? Value of phi will go from 0 to 360 completely. Value of phi will go from 0 to 360 completely. So value of phi will go from 0 to 2 pi. What about value of theta? What will be the range of theta? 90 to 60°. No. From where theta will start? From here theta will start. If I call this as z axis, this as y axis, and this as z axis. So theta will start from here to here. Theta will come from upward to downward. From 90° to, sorry, here what is the value of theta? 0°. I am talking about spherical coordinate system now. I am not saying this is 90° north. No, I am talking about spherical system. Now we are doing this calculation in spherical system. So what is theta here? Theta is the angle measured from z axis. So at z axis, what is the angle? 0°. Now you are coming down. You are coming down. That means here what is the angle? Theta equals to 30°. Because how much angle you need to cover? From 90 to 60 you need to cover. That means 30° you need to cover, no? So here your theta is 0°. And if you are coming down, this angle will be 30°. So you are going from 0° to 30°. Are you getting this point or not? This integration we need to solve. Writing ds was easy for me. Okay, no issue about that. Now I need to take the limit. So phi, I can say phi is the angle measured from s axis. So if I am working on this surface, that means complete phi I am working from 0 to 360. And if I am talking about theta, so for theta I am working from 0° to 30°. That's it. Now people say that spherical coordinate system is not in your syllabus. So if this question is coming into the GATE examination, then mathematics teacher will say that it will be solved by EMFT teacher, and EMFT teacher will say that it will be solved by mathematics teacher, and it will never be solved. Okay, this is what will happen. So certainly spherical coordinate system they did not mention in the syllabus, but every single year the question is coming. Every single year. So without having the knowledge of coordinate system, you cannot even study EMFT. So that's why I spent a lot of time on vector calculus and coordinate system. Not just spherical coordinate system, the question is coming from Cartesian as well, question is coming from cylindrical as well. So from anywhere the question could be coming, and certainly vector calculus and coordinate system is very, very important for your GATE examination. Very important. Like I guess it will come for at least 2 to 3 marks. At least 2 to 3 marks. Here this question was asked for 2 marks as far as I remember. And more questions would come. So this portion is very, very important actually. You cannot ignore it. Okay, and in mathematics, no one teaches spherical coordinate system. So as per me, this question was from EMFT, not from mathematics. Right? So let's add a slide. I guess there is no page left. So which integration we need to solve? This integration we need to solve. So r square sin theta d theta d phi, where phi is going from 0 to 2 pi and theta is going from 0 degree to 30 degree. So r square goes outward, and if you solve the limit of phi, it will be 2 pi. If you solve the limit of sin theta, so integration of sin theta is minus cos theta. So limit will go from 0 degree to 30 degree. So 2 pi r square. Here if I take the minus sign outward, then I can interchange the limit. So what is cos 0? Cos 0 is 1. Right? 0. Cos 0 is 1. What is cos 30? Cos 30 is under root 3 by 2. So what you are getting? Pi r square into 2 minus under root 3. So this is the surface area they were asking. So that's the complete answer. Okay, so this is the answer, pi r square into 2 minus under root 3. So it was a good question, very intelligently framed. If I had been the educator, then I would have asked the lower area. That means my answer would have been 4 pi r square complete area minus the area that I found. I would have said that enclosed by 60 degree north latitude circle that contains south pole in its interior. If I have written south pole here, then answer would have been this area. But they did not ask this question, they asked about this particular area. So answer would be 2 minus under root 3 pi r square. It was a good question. Okay. Now let's solve some questions on antenna, because in antenna we did not solve, like we solved enough question I guess in antenna, but let's solve more questions. Here we are going to solve those questions which are perfectly formula based. Now this question is analysis based, but after that we are only going to solve questions which are formula based. Okay, so those formula based question has been asked previously, very previously in 90s those question has been asked, but since you will find those question in PYQs, so that's why we are solving it here. But this is a good question. I should have taught it in the theory lecture only, but now we are studying it. So this is a good question. You need to find the number of lobes in radiation pattern. So there is two antennas. This is gate PYQ only. Two antennas are there. In both of the antenna, I0 current is flowing. The separation is 2 lambda. You need to find the number of lobes in radiation pattern. So they did not mention about they did not mention about antenna at all. What we are going to find? We are going to find only array factor. We will find the radiation pattern of only array factor. In that array factor, we will see how many lobes are there. Okay. So let's find the array factor now. So how will I find the array factor? So in between at an origin, in between at the origin, I will assume that I am having another antenna. So how will I write down the array factor? So what is the phase of this current? 0 degree. E to the power j beta from the origin towards I0. And if I calculate this angle could be measured from z axis, that is theta only. The angle is measured from z axis. So from the origin from origin towards this antenna 1, from the origin towards antenna 1, I am writing down the distance. What is the distance? Lambda. And what is the angle between this vector and this vector? The angle is theta, cos theta, plus, now let's write down for this one. What is the phase of this current? 0 degree. E to the power j beta from here towards this antenna 2. From this point towards antenna 2, what is the distance? Lambda. And what is the angle between them? This angle, this vector and this vector ar cap. What is the angle between them? 180 minus theta. So angle is cos 180 minus theta. Say yes or no? So what this would be? Minus cos theta. Right? I hope you are getting this point, because if you have studied your antenna theory, if you have studied antenna array from this particular playlist, then you would be able to write down this step. Right? Otherwise it would be difficult. If you are mugging up the formula, then it would be difficult. Just from here to here you see this vector and then you write down the angle between them, and from here to here you go, you write down the distance vector and then you write down the angle between them. Here the angle is theta and otherwise the angle is 180 minus theta. So this you must have already studied. So what is the phase difference now? You can take any phase difference from here to here or from otherwise as well, but I am writing from positive to negative, so that would be 2 beta lambda cos theta. So what is your 2 beta lambda? 2 pi. So 4 pi cos theta. Okay. Now what I will find? I will find the position of nulls only, because what I need to tell? I need to tell the number of lobes. So I'm not finding the position of maxima. I'm only finding the position of nulls, because if I know the nulls, let us say if I know these two are the nulls, so in between there will be one lobe. So between two nulls there is one lobe, that I know. So I'm only going to find what I'm going to find. I'm only going to find the position of nulls, because if I know the position of nulls, then I can draw the radiation pattern. So I am finding the position of nulls. So 4 pi cos theta should be equals to your phase difference should be equals to 2n plus 1 pi. That should be equals to 4 pi cos theta. So cos theta is equals to 2n plus 1 by 4. So value of n I put cos theta equals to n. If I put 0, so cos theta is equals to 1 by 4. If I put n equals to 1, so cos theta is equals to 3 by 4. If I put n equals to minus 1, so cos theta is equals to, if I put minus 1, so it would be minus 1 by 4. And if I put n equals to plus 1, if I put n equals to 2, if I put n equals to 2, so 4 plus 1, 5 by 4, not acceptable. But if I put n equals to minus 2, if I put n equals to minus 2, so minus 4 plus 1, minus 3 by 4. So cos theta is minus 3 by 4. And all these value will be acceptable, because what is the range of theta? All these value will be acceptable. Why is that so? Because what will be the range of theta? The range of theta is from 0 degree to 180 degree. And if you draw the graph of cos, then from 0 degree to 180 degree, all the values you are getting. From minus 1, from plus 1 to minus 1, everything you are getting. From 0 to 180 degree, this is the graph of cos from 0 to 180 degree. This is your 0 degree. So if you draw the graph of cos, that means cos theta equal to 1 by 4. That will be there between 0 to 180 degree. Cos theta equals to 3 by 4. That will be there between 0 to 180 degree. Cos theta equals to minus 1 by 4. That will also be there. And cos theta equals to minus 3 by 4. That will also be there. So all these values are acceptable. So this would be some theta 1. This would be some theta 2. This would be some theta 3. And this would be some theta 4. I am not finding the location of nulls. I am just getting to know that between the range of 0 to 180 degree, there are 4 nulls. So if I draw the radiation pattern, what will I get to know? There will be 4 nulls. That would be like somewhat around, I don't know what value will be there, but some theta 1, some theta 2 would also be there. What I mean to say is that this is your theta equals to 0 degree. This is your theta equals to 90 degree. And this is theta equals to 180 degree. And this is theta equals to 90 degree. So between 0 to 90 degree, there will be 2 nulls. Why is that so? Because this is your 90 degree in cos graph. So between 0 to 90 degree, there will be this null and this null. Positive values. Between 0 to 90 degree, cos will have positive value. So 1 by 4 will be occurring somewhere here and 3 by 4 will be occurring somewhere here. Are you getting this point or not? So what will be this point? This will be theta 2. Why it is theta 2? Because 3 by 4 will be occurring for a lesser value of theta. So this will be theta 2 and this will be theta 1. Are you getting this point or not? Now talking about minus 1 by 4. So minus 1 by 4 will be occurring somewhere here. That is greater than 90 degree angle. So I will make the same kind of values here as well, because it will be symmetric. So same nulls you will be getting here as well. And now you will have at theta 3 you will have another null. So this is the location of nulls. We are drawing the location of nulls, and another null you will be having here. Here also you are having a null, and here also you are having a null. So this is your theta 3 and this is your theta 4. So these are the locations of nulls. This is theta 2, theta 1, theta 3 and theta 4. So between two nulls there will be one lobe. 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 Between two nulls there will be one lobe, and between two nulls there will be one lobe. 1, 2, 3, 4, 5, 6, 7, 8. 8 lobes are there. So number of lobes are 8. A very good question. A very good question. Now I am not sure about the radiation pattern. Why is that so? Like which will have more amplitude, which will be maxima, which will have amplitude till 2, which will have amplitude till 1. I'm not sure about that. Are you getting this point? Like I am not sure that all lobes will have the same maximum value. it can have lesser value as well. If you remember the radiation pattern for 3 by 2 lambda dipole antenna, what was the scene? That this guy was having more, this guy was having lesser, and then this guy was having more. So this kind of pattern was there. So here I'm not sure that what is the directivity of this lobe. What is the directivity of this lobe? I'm not sure about that. That till what point it will radiate, that I don't know. But I'm pretty sure that number of lobes will be 8. So this kind of questions you can expect in your examination from antennas. So rather than mugging up formulas, if you solve by this concept, then there is no chance of error. Like for number of lobes, you will find like students mug up some formula for number of lobes, but those formula will not work always. Those are only for specific cases. But in the examination, certainly if they are asking the questions in upcoming gate examination, they will never ask you standard cases. They will ask you these kind of questions where you need to make the diagram. If you make the diagram, you are clear now that how many number of lobes are there. Is that okay for you? Okay, then let's move to the next one. For a broadside array, find the first null beam width if 20 if 20 isotropic radiators are equally spaced at a distance of lambda by 2. So what is the value of n? 20. What is the value of d? Lambda by 2. What is the value what you need to find? First null beam width. So there was some formula that I wrote down. If you don't remember it, then also it is fine. But there is very rare chance that 0.001% chance is there that these kind of questions will be coming. But these are asked in some 90s, gate 90s. These are asked in gate 90s. So when you solve the PYQs or when you solve the test series, these kind of questions will be there. So do not think that your teacher did not teach you well. Your teacher has taught you well for upcoming gate examination, not for the previous gate examination. Okay. So I don't know why coaching institute frame these kind of questions in test series. So what happens is that you will study antenna completely and you will find these kind of questions in test series, and then you feel like that PrepFusion is not a good resource to study. So this is what happens. This is what coaching institute does. They frame these kind of questions in their test series. So if you see these kind of questions, if you don't remember the formula, just drop it. There is very rare chance of this kind of question coming into examination. But since these has been asked in previous year gate questions, that's why we are seeing it, and for your test series purpose. Okay. So yeah, if you see these kind of questions in test series, your job is to ignore it if you don't remember the formula. But if you remember the formula, then you can apply it and get the answer. But there is 0.001% chance is there that it would be asked in your upcoming gate examination. Is that okay for you? And in PrepFusion test series, you will never find these kind of questions, because PrepFusion test series we ourselves design. We make all the solution. Look, we do not make all the questions. Like 50% of the questions I get from someone else, and 50% of the question I frame by my own. If I talk about PrepFusion test series, and 100% of the solutions will be made by me. Questions will be framed by 50% of the questions from someone else and 50% from me. And these questions are also framed by gate ECE. So I'm not taking their name, but they are framing this question. Okay, like not always he is framing the question, but some other guy is also framing the question. But mostly questions we get from him. So and these 50 questions I myself frame. And if Anish sir is also there, so Anish sir also frames some questions. So then we are not going to frame these kind of questions there in the test series, because we know this is not relevant for your gate examination. But usually in other test series, like some random gate rankers frame questions. So these kind of questions you would see in test series. So don't be demotivated if you see these kind of questions in the test series. Okay. So what is your first null beam width? What is the formula for that? That is, I hope I remember the formula. That is 2 lambda into n minus 1 into d. So yes or no? This is for broadside array, right? Yeah, this is the formula. So lambda value is not given, so let's keep it as it is. N minus 1, 19 into d lambda by 2. So what you are getting? 4 by 19. But certainly it is in degree, sorry, it is in radian. This answer is in radian. So 4 by 19 is in radian. 4 by 19 is in radian, but I need to convert it. So where is my calculator? Here is my calculator. So if you know that pi radian is equals to 180 degree, 1 radian would be equals to 180 by pi. So 14 by 19 radian would be equals to 14 by 19 into 180 by pi. So this much degree I will get. So 14 by 19 into 180 by pi. So roughly around 12 degree I am getting. Roughly around 12 degree. So this is the answer. Okay, is this answer correct? Do I have the answers? No, but I guess calculation is fine. This is getting concerned. 19 to 4 by 19, so roughly around 12 degrees is the answer, but very rare chance that these kind of questions would be coming. Let's see more questions. So there is a there is a formula for directivity. Formula for directivity if half power beamwidths are mentioned. What is that? 40 41 to 53, 14,000 to 53 degree divided by half power beamwidth of E plane, half power beamwidth of E plane, and half power beamwidth of H plane. Will you be able to remember it? 41 to 53. Like, not exactly, you don't need to remember the exact data. Just remember that it is somewhat around 42,000. It is somewhat around 42,000. Just remember this data. It is somewhat around 42,000, or you can remember the exact one as well. 41 to 53 divided by half power beamwidth of E plane into half power beamwidth of H plane. And if only one beamwidth is mentioned, let's just say beamwidth is mentioned only for one plane, then what you will do? 41 to 53 beamwidth of one plane into beamwidth of another same plane. Like, if only one beamwidth is mentioned, then you will multiply twice. And if different are mentioned, here 100 degree and 60 degree is mentioned. So now you can multiply both of them. So what will be the directivity? Directivity would be 41. Again, these kind of questions, very rare chance, 0.001% chance that these can be asked in your examination. These are asked very like in 90s they are asked. So again, very rare chance, but in test series you will find these kind of questions. So what is theta E? 100 degree into 60 degree. So what you are getting? 41 to 53, 41 to 53 divided by 100 divided by 60. 41 to 53. Okay, so you are getting 6.8755. But what do you need? You need it in dB. In dB you need. So what you need to do? Tan log tan 6.8755. So log tan into tan. So roughly around 8.4 dB you are getting. Roughly around 8.4 dB. In the examination, 8 dB can also be mentioned. In the option, 8 dB can also be mentioned. So you will click on this 8 dB. 8.4 dB can also be mentioned. 10 dB, roughly around 8 value will be mentioned. 8.5 can also be mentioned. So you will click on this 8 dB. Okay. So this is the formula that we applied. Let's see the next one. A parabolic dish antenna has a canicular beam of 2 degree wide. So only one angle is mentioned. They are asking you the directivity. So what is the formula that you remember? 41 to 53. 41 to 53. Is that the formula? Yes. 41 to 53. I also forget it. Divided by 2 degree into 2 degree, because only one width is mentioned. 2 degree into 2 degree. So 41 to 53. 41 to 53 divided by 2 divided by 2. So you are getting some 0.25. But what do we need? We need it in dB. So tan log tan 0.25. So what you are going to do? Log tan into 10. So roughly around 40 dB you are getting. So this option will be mentioned. Okay, 40 dB. Now another point is there. What is that? For a parabolic dish antenna, the value of R for far field. For Hertzian dipole antenna, what was the value of R for far field? Lambda by 6. R should be greater than, this was coming out to be roughly around lambda upon 2 pi. But for parabolic reflector, if in the examination parabolic reflector is mentioned, for a parabolic dish antenna you can say, or parabolic reflector is mentioned, then R should be greater than 2d square by lambda. Okay, very rare chance, again I am saying very rare chance that this could be asked, but if you want to remember it, you can remember it. For far field, R should be greater than 2d square by lambda, but for parabolic dish reflector, if they have given this name, parabolic dish reflector, then only you will apply this formula. Again I am saying, again for this I am saying 0.1% chance. For this I am saying 0.001%, but in the worst case, if examiner, if the question paper setter is not in the mood of framing a question, then he can frame from here. But R should be greater than 2d square by lambda. Okay, so let's see what kind of questions has been framed previously. This was also asked in 90s only. Okay, This was also asked in 90s. So what you need to find? The minimum distance you need to find. So R minimum if you need to find, so that should be equals to 2d square by lambda. So what has been given? Yeah, what is d here? D is the diameter or height of the parabolic dish antenna. Basically, if this is the antenna, then here there will be circular area. I told you about parabolic dish antenna, if you remember. It is circular from the upfront. So if this is circular, then this will have a radius or diameter, you can say. That diameter is d, and it is known as height of antenna as well. Basically, this is height of antenna as well. So they can mention it as a height, or they can mention it as a radius as well, or they can mention it as a diameter as well. So what they have mentioned here, for a 8 feet 2.4 meter parabolic dish antenna, that means they have mentioned the value of d to be 2.4 meter. D is 2.4 meter. Operating at 4 gigahertz, that means what is the value of lambda? Lambda is c by f. So 3 into 10 to the power 8 divided by 4 into 10 to the power 9. So that is 0.075 meter, right? The minimum distance for far field is, okay. So 2d square by lambda, that is your R. So 2.4 square into 2 divided by 0.075. So 153. R is 153.6. So roughly around this much distance is required. Okay, so this is the answer. So that's it about our miscellaneous concepts. So we have seen mostly all the miscellaneous concepts. In the next lecture, what we are going to see, light propagation through optical fiber. Light propagation through optical fiber. So this is also a very important, not very important, but from this as well the question can come. Now whatever that we learned in this slide, in this particular lecture, I don't think any question will be coming from this antenna part. Like this is good one, this is good one. Here I will put important. But after this, I don't think any question can be framed. But for a quick reason, you can see these kind of problems as well. Only a quick reason is required. Okay. Then let's get back. This was very important concept of globe. Okay. So here I will put important. Here also I will put important because this is a good concept. Like this is a concept of EM wave. Here EM wave concept is also used. So this is a good concept. So here also I will put important. Okay. So in waveguide, what kind of losses are there? We discussed it completely. So this is also important as per me. Power loss in conductor, this also I will give importance. Okay. Here I will give 0.01% chance. Again 0.01% chance. Very rare. Once it has been asked, that's why I taught it here. And some guy asked the doubt in the Telegram group as well. So that's why I taught it. Now, previous year, the question was asked on this particular concept. That's why I am calling it important. That's why I am calling this one as important. This one is important for me, reflection coefficient. Okay. And this is decent enough. Decent enough. So here I am putting, I guess 10% chances are there that question can be framed. So let's not write anything. But yeah, you can remember these two formula. These two formula. If you remember this, then two questions has been asked, and those were asked in 2015 and 2016 only. So that's it. That's it about the complete lecture. I hope you enjoyed it completely. Let's see. Let's meet in the next lecture. There we will study about optical fibers. Thank you very much. Okay.